spend here the next 3.5 hours.
Yes, so welcome everyone. My name is Tomasz. I'm a group manager for our DeFi R&D department. As Tomasz mentioned, there is a slight or tiny chance that something may go wrong on the technical side, and some of the faults from the webinar. Yeah,
3.5 hours.
We need to drop from the call, so I would take over. So we have primary Tomasz, we have secondary Tomasz, myself. I will have a pleasure to co-run this session. We'll have multiple guests from various companies, from various Ethereum parts, I would say. So we have folks from Ethereum Foundation, Eigenlayer, Webn, TwinStake, Obol. We'll have folks from Brevan Howard Digital, Metrika, EigenPhi, Dapplion, Alluvial, Lido, and probably many others. So this stream is for you. It's for the community, for the guests. Feel free, like this party is hosted by us for you. Feel free to chime in, chip in, and we're happy to have you here. So have fun and enjoy the show.
Okay, great. So Mario already knows that we want to start with talking about testing. So testing preparation last few months or even longer after the merge, the core developers community switched to thinking about the next upgrade, about deciding what goes in, what goes not in, and stays and waits for Cancun. And how the testing of all of that worked. We spawned so many networks, so it's probably above Mario and Pari, who runs the all the infrastructure DevOps at Ethereum Foundation. So that testing was between two of you. Mario, we'd love to hear from you. Like, are we prepared? Are we ready? Are we tested? Where the risks are?
Hey, yes, definitely. Well, I guess I first introduce myself. My name is Mario Vega. I'm from the Ethereum Foundation. And yeah, my main focus is basically testing and implementing new tests for all the forks. So all the clients can stay in consensus, and they have to test the same set of tests every time, so we can be sure that all the changes that are coming in the fork are successfully implemented by all the clients. And yeah, I guess this new fork compared to the merge is quite a decrease in complexity. I mean, the merge was even the merge, it had a little bit of randomness included because we were migrating from proof of work into proof of stake. So there was a little bit of the randomness that was included in that fork. But this time, I mean, because the switch already happened, everything is much simpler. We have a specific time where everything's going to happen. So in terms of how well do we feel about testing in this fork, it's another league of feeling more relaxed and about what we already tested. So they are definitely more safe.
Okay, any reason that because it seems so much easier that it will be more surprising? How would you compare like the effort on testing of the merge versus testing Shapella and the like? Is it 10x? The merge was 10x more testing, more launch of testing networks, or you simply repeated the same procedure because you're used to the level of effort from the merge and you just applied the same template?
That's a very good question. I think most of the changes that we had to prepare for the merge were related to the tooling. For example, one of the tools that I use the most to test the different combinations of clients is Hive. And before the merge, basically there was no preparation before for the consensus clients. So all that work that had to go into testing the merge is now being basically just reapplied here. And it was so much simpler to just write the new tests using the same tooling than it was in the merge to write everything from scratch. Yeah, it was fairly more complex in that time. So I would say, yeah, like 5 times easier, maybe. Yeah, if I had to say. Also, Perry is, there was, I know there was a lot of tooling on your side that for the merge, there was a lot of complexity that had to be upgrades and all that. And I don't know if you want to add something there.
Yeah, sure. Yeah, I definitely agree that it feels like it's a lot less complex than it was in the merge. But I will also admit that my teammate Barnabas, who's also on the call, pretty much took care of the first month and a half of testing while I was on vacation peacefully. And I think a lot of the initial work was upgrading the tooling and figuring out like what the dependency stack is this time around. I have this already crazy looking dependency graph now as to, for the next fork, what tool should we start upgrading so that the last tool would be unblocked by the previous one. And it's actually quite insane as to which library depends on which one and which types and who has what, just from the testing side, not even touching any of the clients. Yeah, it's quite fun. And maybe Barnabas has some more thoughts on the first chaotic month of testing where everything was breaking and there were 5 testnet restarts a day or something.
Yeah, sure. So right after the merge, we decided to launch a Shandong testnet where we wanted to test out to start from a merge state. That was a very major point for us because if we can start from a merge genesis state, then we don't have to pretty much anything that has happened with merge, but we can assume that the merge has happened. So therefore, we don't have to start a POA or a POW proof of work chain and just start from proof of stake chain, which made everything a lot easier. And then a couple of months later, in December, we started the first withdrawal devnet. In middle of December and beginning of January, we actually decided what we would like to include in Shapella. And we were focusing on those EIPs, and we were ensuring that we tested a lot of validators at the same time, trying to deposit, trying to pressure and stress as the network as much as possible. And this was very useful. Within 1 week, we managed to have DevNet, and we found lots of problems. We solved all those problems, and hopefully everything will be great after all this testing. And then in the beginning of February, we started the public testnet, the Chachang testnet, and here everyone could already join in and test all their withdrawal activities and see how withdrawals works.
I think one other thing to add from what Mario was saying was that now that all the tooling had been consolidated, we were able to test not just one upgrade, we were testing an upgrade without knowing what was going in and doing a lot of parallel testing. So we had testnets for EOF, 4844, withdrawals, as well as whatever was supposed to be Shapellas, all running parallelly at the same time with different people able to take care of different things. And that, I think, would have been impossible at the merge. At the merge, everyone was just focused on the merge, nothing else. But right now, we were able to like split things out. We have like these modular testing tools. We have scripts that run set up testnets, and they're all generic enough that it doesn't matter what the upgrade is. We're able to like tune them easily enough that we can test 3, 4, 5 up. Oh, Verkle was the 4th one. Sorry, we're also actively testing Verkle the whole time in the background. And I have to say that's been something we're getting really good at over the last like half a year.
Yeah, if I may add, also we have there's a new repository for execution consensus tests that we are effectively using for Shapella. We started with we actually started with Shapella. So basically, this repository is another place to write Ethereum tests for all the execution clients. And the advantage here is that, as Pari said, there are some times that you don't really know if a change or an EIP is going to make it into a fork. So you have to be very conscious of all the interactions between all the updates that happen. So what happens if a EIP is withdrawn from the fork? Then you have to change all the testing. But in this case, with this new repository, we can write tests in a more modular fashion, such that if there's something that is removed from the fork, you can easily change the tests automatically to test only what's remaining in the update.
Okay, that makes everyone much more comfortable in waiting for Shapella. So probably everyone who is listening knows at least a lot of testing has been done. You remember for the merge, it was the same. The merge was super smooth. We remember that we kind of waited for this Millennium bag to happen at the merge time, and no, nothing bad happened. Some minor issues that actually didn't get any publicity. So Łukasz, Marek, on our side, I think that you've been building Nethermind core for years now, and you went through the merge. Now you were going for Shapella with the team that Daniel was helping to build. And let me quickly check if we have on the call. Ahmad from the core team as well at Nethermind. And do we have anyone else from the core team? There is Ben, there is Damian. So practically good representation of our core team that was preparing for Shapella and previously for the merge. So I would love to hear from you of how that story looked, how prepared we are, what it meant to build that from the core development team, how was the cooperation with the teams, with testing teams, with the infrastructure teams. Łukasz?
So one thing I want to add is big kudos to what Pari, Mario, and Barnabas and all the DevOps in Ethereum Foundation built. I'm really super impressed about the not just testing Shapella, because okay, that's expected and fairly straightforward to do one, but doing so many streams in parallel. We will talk later what's coming next, but testing Verkle, testing 4844, doing EOF, like I'm losing track what's going on, and I'm just working on implementation on one of the client and like testing like 9 clients in different configurations with different configuration. Each client is configured a bit differently. It's just mind-blowing, all the combinations here. So yeah, that's a great work. That's super impressive. And as Shapella, I would say Shapella itself is fairly self-contained. It wasn't that hard to build. So that there are only like 4 ERPs, and three of them are quite small. So there were a few things to figure out, and Marek probably knows more. A few things around like maybe how to correctly version the engine API, because now we will have upgrades and we will be changing things. So so a few things about the versioning. Also doing all these things in parallel, like I said, is hard. So firstly, we wanted to improve things post-merge, like for example, attestation performance and things like that. Secondly, all the other work streams that are going in parallel is like overwhelming a bit, because we have those vertical trees, the EOF, everything here. So quite a lot of things going on, and I think each client is also taking a lot of effort to rebuild things internally to just make better usage of resources, better stability, better modularity. And I'm not only talking about Nevermind. I think some similar things are done in Gaffer, Erigon, and Besu. So like everything is maturing so much, and doing all these things in parallel is challenging. And thankfully, we have a bigger team than we had earlier. And yeah, that's really it. Shapella itself was, I'm pretty calm about this hard fork. Like I think I'm the calmest ever, just because there was so much testing and the test tools are so good right now, and Shapella itself wasn't that big. Bigger things are coming, but I'm really happy that we managed to like put the dot on the proof of stake, because I think Shapella is like finishing the proof of stake transition. It's really needed here. And I'm extremely impressed about like the whole velocity of the Ethereum ecosystem, of the core devs of Ethereum. So like I said, doing all those streams in parallel is just mind-blowing how fast it's coming through. And I will leave Marek maybe to add more details.
Yes, so first of all, I agree with Łukasz. Huge kudos for Mario, Pari, and Barnabas for all the testing. It's amazing. And I think we are very well prepared. And as Mario said, compared to the merge, there was lots of edge cases that could happen. And Mario wrote some really different scenarios for the merge transition that never happened, but there was lots of probability that something bad will happen. So compared to Shapella is much more easier, but I wouldn't of course underestimate it, because I think we also grow as a team in Nethermind internally. So it was much easier because we hire lots of good people just before the merge, and they help us with Shapella. And if we had to do everything with like the same team that we were before the merge on London time, it could be hard for us. As Łukasz added, there is lots of things going on. There is EOF, vertical trees, 4844, and we won't be able to handle everything without lots of new people. And about Shapella, probably the biggest VIP was Withdrawals. And the logic behind Withdrawals are quite simple, because we just need to increase the balance that we receive from consensus client. But of course, there are some edge cases scenarios, and but yeah, I think as I said before, we are well prepared and looking forward for this hard fork.
And we very much look from the execution layer client perspective. So you have to take into account that like here we're talking about execution layer. That's why we mentioned the clients on execution layer side. That's was like Nethermind's perspective. Do we have actually someone on the call from the consensus layer side? It might be that not, but please shout if there is someone. I'm just scanning quickly. No, I'm like, but if we have joiners later from one of the consensus layer clients teams, would be great to hear. There is much more to cover on the core side of the development side, the various forks that are incoming, what we'll do there. But I would like to keep jumping a bit between the topics to cater to various needs of our listeners. So we have Justin. Is Justin already on the call? Justin Trolley. Okay. So we give Justin a moment after first talking about the BLS. I mean, it might be actually close to the security and testing. So I'd love to ask the crypto research team at Nethermind to have a bit coverage on the BLS signatures. What really happens there? Why do we have to look at BLS signatures in the context of Shapella withdrawals? The basic info is that many of the stakers recently are preparing for the transition of the key format, and let's cover that topic. Let's give it 10-15 minutes. I believe that Ahmed can start with a short explanation.
Yeah, sure. Actually, I would like to start with the general definition, maybe on digital signatures. And then we have digital signatures, and digital signatures are cryptographic protocols that are used to authenticate a message on behalf of an individual. I mean, it is similar to the classical signature case. I mean, like an individual putting his signature at the end of a document he created to certify his identity over that document. For example, when a user wants to send a transaction on Ethereum, he prepares a transaction and then he signs it to certify his identity and approve the data on that transaction, right? And in general, the digital signature schemes basically consist of 3 algorithms. And the first one is key generation, in which user selects a secret key, and then this secret key will be used for signature generation. And also he computes the corresponding public key, which is used for verification. And in the second algorithm that digital signature scheme has is the signature generation algorithm, in which user signs the message with a secret key. And the third one is verification algorithm. And in the verification algorithm, any verifier who is given a message, a signature, and the public key of the signer can verify the signature, whether it is valid or not. And also, the BLS is also a kind of a digital signature scheme, and it was proposed by Bonnet, Lin, and Shacham in 2001. Actually, in a very well-known paper, short signatures from whale pairing, and these BLS signatures work over pairing-friendly elliptic curves, in which we have basically 3 operations available, different from some other the other signature schemes. These operations are point addition, elliptic point addition, scalar multiplication, and billionaire pairings. And in general, BLS signatures also consist of 3 algorithms. And in a key generation of BLS signatures, users just picks a secret scalar key from a predetermined field, and then computes his public key by a scalar multiplication. And in signing phase, the user first represents its message with a point on an elliptic curve, then generates the signature by just computing a scalar multiplication again. And in the verification phase, the verifier given a message, a signature, and a public key, just verify the signature by using bilinear pairings here.
Yeah, maybe you could tell us what's so special about BLS signatures.
Yeah, okay. I can tell about the properties of BLS signatures. Maybe one can ask. Okay, we have ECDSA signature. We are using it for signing transactions on Ethereum. So why do we need another signature like BLS for the consensus purposes? So yes, we have ECDSA signatures, and actually the verification of the ECDSA signatures are cheaper than verification of BLS signature. However, BLS signatures have some other special properties. For example, they are deterministic signatures, meaning that they do not include any randomness in the signature generation phase. In other words, we have same messages with same secret key, and it will result in the same signature. For example, in Schnorr-like signatures, like ECDSA signature, users need to add a randomness in the signatures for each time they sign. This makes Schnorr-like signatures hard to aggregate, but the fact that BLS signatures are deterministic, this makes them easy to aggregate, and we can easily enhance BLS signatures to obtain a BLS multi-signature or BLS threshold signatures. This is a very cool property, and using this property, I can say that the second, maybe the most important property of BLS signatures is that they are aggregatable, and they are fully aggregatable. Maybe I can share a figure to make it more comprehensible, but I am disabled now. Okay. Okay. No worries, I can go ahead. Okay. And as I said, the BLS signatures are fully aggregatable, and this means that we can compress many signatures into a single signature by simply summing them up by computing an elliptical addition, which is a cheap operation, a relatively cheap operation.
I mean, sorry for interrupting you, but you can share the screen now, so maybe like some visual material will be helpful here.
Cool, thanks a lot. Yeah, can you see my screen?
Yep.
Cool. As I said before, the aggregation property allows us to aggregate public keys and signatures, and then verify many signatures just on verification. As you can see here in the slide, let's say we have 3 public keys, 3 signatures, 3 public keys of 3 signers, and also we have on the right-hand side, we can see we have 3 different signatures on the same message. We can simply sum these public keys to get aggregated public key, and then we can sum the signatures to get an aggregated signature. And you can see at the bottom of this slide, the verification equation, the verification operation is just the same as a single verification of a single signature. So why this matters? Because in each slot of the Ethereum, there are some a proposer below, and some subset of the validators attest to this block. So there are hundreds of signatures, and these attestations are nothing but BLS signatures. So in order to make it efficient, we can aggregate all the attestations into one, and then we can verify all the attestations by just verifying a BLS signature, a single BLS signature, right?
Yeah. So the BLS signature scheme used in Ethereum is slightly different from the BLS signature introduced in the paper, right?
Yeah, exactly. That's a very good point. Thank you very much for reminding this. In BLS signature, we have 2 groups, which are used for the spaces where the public keys and signatures live, and the size of this, let's name this groups G1 and G2, and the size of the elements of these groups and the computational complexities of the operations in these groups are not the same. In particular, G1 has smaller elements than of G2, and operations in G1 is cheaper than in G2. And usually, when a cryptographer designs a signature scheme, he wants the signature size as small as possible because of the communication complexity concerns. So it is reasonable to say that the signatures should be the element of G1, and the public keys should be the element of G2. But Ethereum Foundation's choice is just the opposite way, I can say. Ethereum Foundation specifies the public keys as G1, which are the G1 elements, which are the smaller ones, and the signatures as G2 elements, which are the bigger one, and respectively they are 48 bytes and 96 bytes, because of the elliptical curve that they chose. And there are a couple of reasons behind this choice. First one, maybe I can say that.
I will, since we started much later than we planned, I'll try to limit the theoretical part of our coverage of BLS and ask about the very specific reasons why BLS is important in the context of Shapella. So I would like to talk about the BLS to one address conversion on Ethereum 2, because this is a big part of the event. And then we'll try to transition to some coverage of data and a few other concepts before the actual transition in 1 hour and 10 minutes, I believe, from now. So since we have slightly less time, let's get to the actual beats that are relevant for the Ethereum 2 now in Shapella.
Okay. In terms of withdrawals, we use BLS signatures because I mean each validator has two sets of keys. The first one is validator set, and the second one is withdrawal set. Users during the depositing their 32 ETH to the deposit contract, they send with this 32 ETH, they also send the validator public key and the withdrawal credential to the deposit contract. So other validators will use this information to verify the signatures in the consensus part. The validators use this secret validator key for signing block proposal and attestations. And also they sign a signed voluntary exit message, which is needed to exit the active validators. So they initiate the system, they initiate the withdrawal process with the validation. And the withdrawal private key is used by the validator when it wants to remove its deposit. And it rewards after it has exited the active validator set of validators. Active set of validators. Yeah, and since the BLS signatures are fully aggregatable, I can say that we can aggregate many withdrawal requests, many exit requests into one signature. Since they are also a BLS signature, we can aggregate into one, and we can verify many requests by just verifying one BLS signature scheme. Yeah.
Yeah. So practically, thanks to this technology on BLS, we have much less of a network requirements and the storage requirements for the signatures data. So without that, we wouldn't be really able to operate with the number of validators that we see in Ethereum and to process the all the commands from the validators at the speed as we can now. Now the question is this transition from the BLS keys to ETH1 keys, addresses on the withdrawals. How have we tested that, and where we stand in a preparation? What should we expect to happen at Shapella transition? What happened already? What is the specific operation that is being executed now by everyone who was on the BLS keys? Can we cover that? And I here invite everyone to chime in, like whether you participate in testing or you're planning to observe the data for that and would like to share how we will be able to observe it. It affects also a bit of the withdrawal indexes and so on.
I could share a little bit about the data.
Please.
So for those watching live on YouTube, I actually shared the link to this app called Metrika. And by the way, we also have guests from Metrika. So I'll tell you more about the app and the data that you'll be able to see on their app. But basically, if you use that link, go to the Metrika app. Under Network Dashboards, you'll see Withdrawals Overview. And there you'll see a section that says 0x01 withdrawal addresses set. So currently that number stands at 43%. So what that means is at the moment, 43% of the validator set has switched to the correct withdrawal addresses that will enable them to withdraw. So this is actually important because this was one of the largest articles that we're working on, gauging the demand for withdrawals post Shapella, and we're keeping an eye on this number because anyone who wants to withdraw essentially will have to switch to these addresses, and you can use this website to gauge basically the percentage of the validator sets that is ready to withdraw. When it comes to the actual process of switching, I think I'll leave it to the core team, which is more knowledgeable than me, I think.
Waiting now for someone to jump in and explain to people what exactly has to be done to switch, to execute that process.
So I can say, so there's a pretty useful tool called ETHDo, ETHDo, I've only seen it written down. I don't actually know how you pronounce that, but it's got good guides online for any validators that want to create the signed BLS to execution message change. Pretty easy to, yeah. Jim, maintains that and does a great job. And yeah, the instructions are pretty easy to follow. And the result of that is you get a signed message, and a node operator can then, there's a command that they can run on their node to get that message change loaded on the node, and it will get gossiped around the network and included in a block. There was also quite there was an interesting effort called CLWP, Consensus Layer Withdrawal Protection, where it aimed to ensure that the rightful owner of a validator sets the withdrawal address, because there was a risk that in the last 2 years some validator keys may have been compromised. So they could upload their credential change message early, get it sort of vetted, and then that gets distributed across a whole range of partners, and any node operator can volunteer as well to run the CLWP set, and that just gives it the highest chance that these messages are included first, before any nefarious actor who may have access to a validator's keys can set it to their own withdrawal address.
Thank you, Taran, for saving us here, explaining the links are shared on YouTube, I believe, here on our chat as well. So I have here the nodes.ethereum.org withdrawals guide. So if someone could share it on YouTube as well, that would be great. So one reminder, without executing that, if you're on the old scheme, then practically you cannot participate in withdrawals. It doesn't mean that anything disappears, that you lose the assets. It just means that it will wait until that conversion actually happens, the migration happens, and then the withdrawal and exit are two different operations, or two different concepts. The exit is stopping validating, withdrawals is just continuous shaving off anything on top of 32 ETH, and then after exit actually withdrawing all the assets to the address. So you can think of that staying on the old credentials is just waiting to activate them later and withdrawing everything. So it's like joining Shapella after a delay, putting everything on pause. All right, thank you. And since we already started about talking about the data tracking, I would love, there will be lots of other topics and I'm mixing them here, but I would love maybe to give 2-3 minutes to everyone who represents here the data teams, dashboard teams, to give a short info of like, where do you think is the best to track the Shapella on your dashboards? Like, what would you recommend the users of your projects to look at, and why is it important? Why did you choose these dashboards and not the others? Maybe starting with Metrika, since we already had Taran talking.
Yeah, I can continue. So there's 2 dashboards that we've produced that are relevant to this upgrade. We've got our network upgrades dashboard and our withdrawals overview dashboard. Shall I share my screen for those?
Yes, please.
Yeah. There we go. Can you see that?
Yes.
Oh. Yeah, so this is the network upgrade dashboard. I guess I'll caveat both of our dashboards by saying that we're not a sort of block tracker, like the data that we collect sort of takes longer to collect, and we aggregate it over larger periods of time. So we're not expecting anything particularly instant to happen as the timer reaches 0. We are more just looking for a longer term analysis and network readiness over a longer period of time. So this one, we wanted to determine that the readiness of the nodes on the network, because obviously the nodes need to be upgraded to compatible client versions. So we were tracking the releases of the clients teams up to as we approached this. They've now all released versions that are compatible, and we've created a crawler that crawls the network and finds from the nodes what their client version is and checks that they're running compatible versions. I don't know if Alvaro, you want to say anything more about this?
I can weigh in a little bit here, Torin, as well. So on a high level here, the concept of network readiness is very simple. We're just trying to answer the question, have the nodes fully upgraded and are they ready for the hard fork epoch, basically. So as Torin said, what we did is we sort of piggybacked off the consensus layer, the P2P protocol, and we crawl the network every 6 hours, scanning as many nodes as we can, and we are collecting data around the node's identity and status. And some of this data is really important in this use case, in the use case of the network upgrade. And so we basically identify the compatible client versions as you saw them in the client readiness section. And we basically plot them here so you can see what part of our sample is already upgraded and ready for the for Shapella. There are a few other interesting tidbits here, like the network fork version that is a value that also kind of works as a signal for the readiness of the nodes, and then the fork digest is a very hard requirement when we pass the hard fork epoch. And then the last section, if you scroll down a little bit, Torin, is more of the kind of, I would say, the fundamental metrics that you would usually see when it comes to the performance of the network in a real-time basis. So we wanted to approach this problem in different phases, if that makes sense. So from the client readiness all the way to the network readiness, and then tracking more of the usual performance metrics. And then, of course, aside of kind of the network upgrade, which should be useful, hopefully, for Deneb and all the others that are coming down the line, obviously, front and center in this upgrade was the withdrawals overview dashboard that we were talking about before as well.
Yeah, so this got mentioned earlier. The OX01 withdrawal addresses, and there's 43% are set now. The CLWP submissions that I mentioned, there were 2,000, just over 2,000 submissions to that. We are visualizing the queues, activation and exit queues. So you can see in the last hour there's been a few activations, and we also want to track how the circulating supply of ETH changes. So this is the ETH on the execution layer. So since the merge, all of the inflation of ETH has been on the consensus layer and locked until now. And the withdrawals will enable the first time that the actual circulating supply on the execution layer can inflate. It's been just in a downward trend ever since the merge. We'll track the number of credential changes. So expecting to see a lot of those at the point of the upgrade as all the CLWP submissions get submitted and everything that everyone's loaded into their nodes in preparation. The balance area is interesting. We can see this large blue area, the withdrawal possible. These are all the exited and slash validators that are waiting for, waiting for this upgrade so that they can retrieve their liquidity. So we should see over the coming days this blue area reduce right down. Average stake and active validators, and then we'll obviously be tracking the withdrawals as they happen, and be looking at the largest withdrawers, which withdrawal addresses are receiving the most withdrawals. It's
Perfect. Thank you so much. Thank you so much. And so I wanted to ask also Brian, if you'd like to show the EigenPhi dashboards. I'm not sure if you have you with us. Do we have Brian on the call?
Yeah, I can see Brian.
On...
Yeah, sure. Just give me a moment.
Sure.
Yeah.
Just for everyone, I'm like changing a bit the ordering. I'm calling people without preparation, so please forgive them for just like sometimes needing a few more seconds. But that's a good pace. Thank you, Brian.
Yeah, so this is our website showing all these current MEV market status at the moment. So you can switch from, I think the best way to watch the Shapella upgrade is to switch to the 24-hour status time frame. So we can see that during the last few hours, how many like arbitrages and how many like sandwiches has been happened. And also we have this live stream going on, like showing all kinds of different arbitrages and sandwiches and those stuff. And also there's leaderboards in terms of both and the transactions here. So I think at the moment, the most thing people need to pay attention to is like the all these different tokens relating to the Shapella upgrade. As I think we can just like switch to the trading volume and show the list. So you can see the STTH has already been like climbed to the number 4th in terms of all the MEVs related stuff, right? So we can just click and show like how many MEVs regarding STTH has been happened during the last few hours. So you can see that it's happening a lot during like all these arbitrages, right? So you can see here. Yeah, some of them actually not making too much money, but I mean, still it's good to see like what's actually happening regarding all these different pegging ETH assets has been going on out there. So yeah, and this is STTH. Like for example, if you want to see like the biggest, like for example, like this one, I think it's better to show this one, like this transaction. You can just click the transaction and show you the. So this one is actually the balance table and like how many tokens has been transferred among different addresses and among different like liquidity pools and those kind of stuff. And you can just switch to the token flow. You can show the exact token flows, transfers, all that kind of stuff happening among these different trading venues. And so it's kind of important to pay more attention to the liquidity pools, right? So for example, this one actually used this Uniswap V2 liquidity pools that has been trading STTH and WTH. So you can see these are the trendings in terms of volume during the last few hours. So it's not too much actually going on in this one, but I think we can switch to the transaction here and click the actual like another pools. Like this one is actually pretty active during the last few hours, right? This is the WTH and the STTH on curve. So you can see the pool remaining has 5,000 WTH and STTH has about like 22,000. So you can see all these MEVs happening in the real time, and the leaderboard so here, all this kind of stuff. And so yeah, I mean, in terms of the way to monitor the real stuff, I think I've already like pasted the link regarding 3 liquidity pools and 3 tokens in the Zoom link, but I can definitely paste them back in the comment section of the YouTube video.
Perfect. Thank you so much. So why do we need to look at MEV? So depending on whether all the information that is there is discounted, we'll see either a lot of volatility or not that much. If there is an agreement on what should happen after Shapella, if there is an agreement that everything goes smooth, or if there is an agreement that actually something goes wrong, then maybe there will be no significant move in the market, less volatility. If there is more, then definitely all the MEV charts should start shooting up. You should start seeing volatility, MEV numbers. You should see validators getting a lot of MEV payments through the MEV boost channels. All of that MEV setup, the PBS, proposer builder separation, was all upgraded to be in line with Shapella. So the upgrades not only to the consensus layer clients, not only to execution layer clients, the upgrades also are relevant for the block builders, for the relayers, for those who run MEV boost next to their validators. So all the node operators need to be ready for Shapella, and this is happening. Most likely everyone is already prepared. Hopefully no solo validators will stay behind and not participate in the network after switch. This will be one question as well. How do we see the solo validators actually maintaining their nodes and tracking all the relevant upgrades, Shapella being the one now. We will cover a bit more about the data, and we have now around 50 minutes, I believe, before the Shapella happens. Please, let's stop sharing the screen now. And the next thing that I would like to cover is some topics related to the validator handling. So coming back a bit to the research space, security space, so talking about the liquid staking and DVT, so distributed validator technology. And I will allow Michał to run the short moderation panels with our guests about these technologies. With the assumption that I think we'll have to compress it slightly in time, not too much, focus on the most relevant things on the Ethereum 2 side now before Shapella, so we can also cover the areas around the data and prepare everyone more with our DeFi research team showing all the different metrics and websites, and maybe core devs chiming in with some more data about how it looks. So Michał, please.
So I see we have Oisín and Collin from Obol Labs. Hi guys. We also have Izzy from Lido. Hi Izzy. So maybe let's start with Obol. Could you make a super short introduction to DVT, what DVT is and what it enables?
Yeah, I can do it. Collin, do you want to take it, or is he gone?
No, sorry, I'm here. I'm having a bit of mic issues, double feedback. You can take it though.
Sure, I'll go for it. So distributed validators at their most simple is, we spend a lot of time talking about the validator key, or this BLS private key. And one of the nice things about BLS that we alluded to earlier is that you can aggregate them and you can do kind of threshold signatures with them quite easily. Distributed validators is the idea of splitting this private key into multiple parts and having multiple humans or multiple entities to work together to run a validator. This is beneficial in particular because it can also add fault tolerance. It's not that if you split it into 4 parts, you need all 4 machines online. You can split it into 4 parts and only need 3 of the 4 machines online. So this is a huge improvement in terms of having high uptime. And it's also a big thing for decentralization and trust minimization, particularly for the liquid staking solutions that, use these operators to stake on their behalf. Using distributed validators massively de-risks them in terms of they're not, giving this, private key with the full 32 ETH to 1 human. It's like, no, you 4 people, you run them together. And so long as 3 of the 4 of you are online, you'll, work correctly, you'll validate and things will continue. I'll pause there and not get into too deep in the weeds in it too soon.
Yeah, but regarding the Shapella update, so it seems a bit complicated, to withdraw a validator that is not a single entity, but it's a number of parties. They may not know each other, not trust each other. yeah, could you tell us like how withdrawals play with DVT?
Yeah, so I will say similar to testing and doing all of the normal duties, if you need broadly more than 2/3 of the private keys like working together. So the same rule would apply to an exit. So if there's 4 people each with a piece of the private key, 3 of them would need to come together and sign the exact same message being like, yeah, exit at this epoch. So there's a little bit of extra coordination versus just one person triggering an exit. But I will tease that I've been plugging away with some of the EF client teams on trying to make this easier, and maybe even trying to get the withdrawal address being able to initiate an exit rather than the hotkey being the one to exit. But yeah, right now to do an exit with the distributed validator, you need a threshold of the node operators to agree to exit. So there is a little bit more coordination overhead than just one person being like, yep, I'm out, time to broadcast my signature.
Cool. Maybe you could also share with us like how the stake is like it's getting back to the validators. How are all the rewards getting back to nodes in the cluster?
Yeah, so that is a good question, and I think one of the main things about this is right now, because of the fact that the kind of ETH2 chain started separately to the ETH1 chain, I know we're not supposed to use those words anymore, there was no communication between the two sides for more or less the last 2 years. And exits will be the first time that there's any major data flow across them, or at least there'll be value flowing one direction. So when it comes to sharing rewards, at the moment, what happens is people will broadly deploy an address that is like an OX01 withdrawal contract or a withdrawal type. And in that they have Solidity. And broadly with Solidity, you can kind of code whatever rules you want. But there is a bit of a kicker with exits, that exits don't work like normal Ethereum transfers. There is no transaction. The balance just kind of changes all of a sudden. And that's kind of tricky because it means you have to do all of your accounting in like when you're trying to withdraw from this address. You can't say, oh, Ether has shown up, let me update a few balances and like do a bit of accounting. That doesn't unfortunately happen. So the trick instead is to do everything in a pull-based method. And that more or less goes to plan. But yeah, how it works is broadly right now, if you want to avoid an oracle or anything like that, every validator normally needs a separate address, and all of the Ether, like the 33 Ether we'll call it, will go to one address, and then you can like go and you send a transaction to pull it. And most times, 32 Ether goes one place, and then the rewards beyond 32 Ether gets divided. We at Obol use OX splits. They build splitter contracts. So we've been deploying those and allowing people to configure to say, hey, the 7 of us want to run a validator. Maybe we're not contributing equally. One person is contributing half and the rest of us are contributing the rest. You can like set up a splitter contract that way where it's like, person 1 gets 50% and the other 6 people get the rest. And yeah, you deploy it, it's immutable, it's uneditable. The Ether shows up there post exit, and then people like pull it into their account. Is broadly how it works. That works at like one validator, but at like Lido scale, that doesn't really work. So you have to do other workarounds then.
Yeah, that's cool. Maybe last question, like what next Ethereum update would you like to see, to make life of DVT providers easier?
Yeah, okay. So I teased it earlier and I'll give a bit more of the game away at the moment. But broadly, one of the things that we've been kind of working with a lot of the kind of teams here with and like the LSPs is around withdrawal address initiated exits. This is something that hasn't
I think Izzy is agreeing with you.
Yeah, exactly. Izzy is exactly who I have in mind. I was like looking at Izzy's community call about like Lido V2, and it's like, yeah, we've done all this, great stuff about like managing signatures. And I was like, we can convince them to change it though. So broadly the aspiration or my, wish list of what to come in is a means for an OX01 withdrawal address to initiate an exit. And the one prerequisite we've identified is being able to read the beacon state route in the EVM. Right now, the EVM kind of doesn't know what's happening in the consensus layer. It knows very little, but there's one EIP from Alex Stokes and others to more or less put this Merkle route in an opcode so you can grab it. And then you can do things like Merkle proofs like, oh yeah, I can prove that this validator's exit details is my address. Therefore, I own it. So I can initiate an exit. And yeah, there's more to come on it. It's not quite like, ready for public pull request yet, but broadly, we've been agitating away for the ability to allow a smart contract to trigger an exit, because broadly for a lot of people that de-risk things, it takes it away from a signature, and it means, oh yeah, we can do it in a smart contract, we can maybe even formally verify it and stuff, but it broadly, in my eyes at least, de-risks the kind of custody side of exiting. Like you asked me at the start, it's like, is it not a lot of work to get 3 or 4 people to coordinate an exit? And frankly, it is a lot of work, and there is a little bit of risk to it. So having a scenario where the withdrawal address, who to some extent is the beneficial owner, allowing them to just broadcast an event from a smart contract, and the validator starts to exit, will probably make a lot of people here's lives a lot easier, or at least that's the goal. So yeah, if you ask me my wish list, it's beacon state route on the road to withdrawal address initiated exits.
Yeah, Marek is taking notes. So. And and maybe with that question, we can make a segue to Lido and Izzy. Yeah, maybe the same question to you. What next Ethereum update would you like to see?
4788, so beacon state route and triggerable exits. These are the linchpins, I think, to, like Oisín said, significant technical de-risking from like a what could go wrong perspective. I don't think triggerable exits, especially if they're triggerable from the execution layer only, will be widely used, because it's going to end up being very expensive to like forcefully exit thousands of validators. But you want it as a last resort for like a lot of different reasons. Either if you have a DVT cluster that is unrecoverable for some reason, or if you have a non-cooperating node operator, or if the node operator wants to cooperate but can't for whatever reason. And then, of course, like 4.8.4 is something that everybody's looking forward to from a user perspective. But I think from a liquid staking protocol perspective, definitely beacon state route and eventually triggerable exits.
Jorge, are you with us?
Yes, I'm here. Can you hear me?
Yep.
Awesome. So should we switch towards on that note, switch towards the topic of liquid staking and how it relates to Ethereum withdrawals?
Sure.
Yeah. Cool.
Sounds good. Okay, so yeah, let's start from the basics here regarding what liquid staking is. For some of you guys in the audience, you may have heard of certain tokens such as STETH, RETH, OSETH. These are known as liquid staking derivatives, and you may have seen there has been a lot of attention brought to these in the days before Shapella. So you may be wondering, what is this all about, and how does it relate to the implementation of Ethereum withdrawals? Well, here we have the honor of hosting one of the best guests we could ask for this, learning more about this topic of liquid staking. And that would be Izzy, who is a contributor at Lido DAO and master of validators. And we at the Nethermind research team have collaborated with Izzy for the past several months as part of a research project that's being delivered to the Lido DAO, of which we could talk a little bit more if time allows. But for the time being, I would just like to start thanking Izzy for joining us, and we would like to talk a little bit about the basics, as we said before. So, okay, we know that Lido is a protocol that makes liquid staking possible. So, what is liquid staking exactly, and why is it valuable for the Ethereum community?
Thanks, Jorge. So first of all, thanks for having me. It's an honor to be here. Above all, I don't know how much of an honor it is for you guys, but thanks for saying that anyway. So let's get right into it. Liquid staking at its basic form, especially like when it was conceived for Ethereum specifically back during like the genesis of the beacon chain, was centered around the idea of how is it possible for the stake, which is usually locked up, and when Ethereum proof of stake came out for an indefinite period of time, given that withdrawals didn't, and technically I guess still don't exist on mainnet, but hopefully that'll change within the next 40 minutes. How do you take this idea of an indefinite lockup and offer users a certain way based on the idea that eventually this lockup will go away and become either a definite or a controllable thing, to access those accrued rewards in a way that is composable with the rest of DeFi on the execution layer, and at the same time still maintain security and promote other things like the decentralization of the network. So what liquid staking tries to do essentially is, one, decrease certain barriers to entry to staking. So usually when you stake, especially if you're running your own validator, you need to stake a minimum of 32 ETH, which is also the maximum for every validator. And so liquid staking basically allows users to contribute to this effort without necessarily having that amount of ETH. And secondly, it allows the rewards that are accumulating as a part of this effort to be accessible and usable in DeFi right away. And the third thing is that it basically allows the representation of the staked ETH and those rewards to be tradable. So it allows not only for optionality with regards to what users choose to do with their capital, but also for like a robust ecosystem to develop within the execution layer over how these funds that are used to secure the network can at the same time be used to create like volume and use for the network. So it creates kind of like a synergy between funds that would usually be doing one thing to allow them to do many different things at the same time. And this really dovetails nicely with the whole idea behind like blockchain and DeFi and money Legos.
That makes sense. Thank you. So for users that want to like be able to like liquidly access these stake tokens, they have a variety of options, right? And the one that has been the main one up to this point in time before Shapella and before the subsequent upgrades to the Lido protocol to synergize with this has been trading the tokens on the secondary market, right? Which and the value of these tokens is contingent upon the promise or the ability to be able to withdraw them through a native mechanism in the future. And so I know that you guys at Lido have been working extremely hard on perhaps the most important upgrade to the protocol up to date, to the point that's being dubbed, it is being dubbed as Lido V2, correct? And part of what Lido V2 is going to achieve is to allow people to interact with Lido and deposit liquid staking tokens such as esteemed and be able to withdraw its equivalent value on ETH, correct? So exactly how does this process look like? And so technically speaking, what are some interesting things that that happen during the process of withdrawals?
Yeah, that's a great question. So, I mean, technically, if you're thinking about it, if you want to look at withdrawals atomically, what it means, like in native staking, is that actually you would be exiting a full validator and receiving back the remaining balance, whatever it happens to be, based on how many partial exits happen in between when the validator gets fully exited and withdrawable, to the point where it gets withdrawn and you get that balance on the execution layer. For liquid staking protocols, this can work a little bit differently based on like what the actual withdrawal mechanics look like. So in the case of Lido, there is actually a buffer that is filled throughout the day based on different sources of ETH. Those sources might be deposits that are incoming and then have not yet been deposited to the beacon chain. They might be rewards that are coming from the beacon chain back to the execution layer. So for example, like partial withdrawals or full withdrawals from exiting validators. And they may also come in the form of execution layer rewards, so basically priority fees and MEV that are again being swept on a daily basis and added to this buffer. What contributors for Lido are designing as a part of V2 is that this buffer will be made available to sate the need for withdrawals as the primary resource. And so basically, if there's ever ETH available in the buffer, it will be first used to meet demand for withdrawals and redemption for those withdrawals. And then if there isn't enough ETH in the buffer, then validator exits will be triggered to meet this demand. Some staking protocols may not necessarily be able to trigger validator exits. Well, directly right now, few of them can. Indirectly, a lot of them are designing mechanisms to do that. And they're all, at least some ways, not necessarily triggerable exits to the extent that we were discussing earlier with Oisín, but ways to kind of like pre-sign exit messages, store them somewhere, either centrally or in a threshold encrypted manner, and access those messages if they're needed in like kind of dire circumstances. So the real kind of user or usability and simplicity unlock here is combining the buffer on the execution layer side with determining how many validator exits need to be affected on the consensus layer side in order to meet the withdrawal demand as effectively as possible while maintaining capital efficiency.
That makes a lot of sense. Thank you. So it would seem that this buffer or intermediate layer can make it so that if there is liquidity available, a user is able to withdraw much quicker than they would be able to if they had to like interact with a native staking mechanism, correct?
Correct. So like obviously the buffer is the directly available method, and there you would get, you know, one-to-one STETH to ETH plus any accumulated rewards. And the secondary direct mechanism there is, like you were saying earlier, secondary markets. And so depending on kind of like the time preference of the user that wants to withdraw, there's a lot of different options that they have in terms of determining what their preferred course of action is. They could swap STETH for ETH or any other token on secondary markets. They could lodge a withdrawal request via the primary market, i.e. the Lido staking protocol, and get it either semi-instantly, basically within 24 hours if there's enough ETH in the buffer, or over a longer period of time if that validator exits need to be affected. But there's an interesting property that is designed as a part of Lido v2 that is also afforded, and that's basically that when somebody creates a withdrawal request, they get an NFT that represents this withdrawal queue position. And this NFT can be traded basically like any other token. And so we envisage that eventually there may be markets where these tokens are being traded at a certain value discounted relative to the amount of ETH withdrawals that they represent. That is a discount somewhere in between what the secondary market price would be for exchanging this ETH and what the full par value would be if you wait for the full length of the withdrawal.
That's very interesting. It's like a very well thought out process from what I can see.
Thanks. And I didn't design it, so all credit goes to somebody else.
Right. Now, speaking of that, so like, I mean, I can only imagine for a protocol this complex and with this much capital at stake, like just how complicated or how high stakes the process of shipping an upgrade like this one would be. So, but by no means this question is meant to rush or anything. But what's regarding the timeline for STETH withdrawals being available on Lido, what can end users expect?
So I think the updates that were shared most recently by the contributors that have kind of like an overview of this is shooting for early May, like within the first half of May. But the real honest answer here, I guess, is like in Valve time, basically when it's ready. This is one of the most important things to get right. Doing as many tests as possible, running through the code and auditing it as many times as possible with as many different parties as possible, bug bounties, doing full integration tests and end-to-end tests with, like, for example, we are running with all of the node operators, a full end-to-end test for all of the different scenarios that we can come up with regards to validator exits and how that might work. So these things take time. Obviously, we can't cover all cases, but we are trying to think of all the things that need to be covered in order to ensure the best experience for users when this does go live.
Right. I read earlier that the protocol is going to be, or has been audited 7 times, and that there is formal verification that will be done as well.
Yeah, so the audits, not all 7 correspond to the entire code base, but I think, for example, the code base around staking router and withdrawals separately or by the same auditor have been covered at least 3 times each. and formal verification around withdrawals. Yes.
That's fantastic. I commend you guys for being that careful with the shipment of the update.
Yeah, those aren't done yet though, so we're still waiting for all of those finalized results, of course, and those are one of the first kind of like arbiters in terms of determining the readiness of the protocol for mainnet.
That makes a lot of sense. So just as a final question, and I mean a wrap-up question, are there any new features or developments on the horizon for Lido that you would like to share with us?
So the other part of the proposed Lido v2 upgrade is what's called the staking router, and this is probably the most important piece of infrastructure in terms of outlining what the Lido of the future might look like. So the upgrade has been dubbed v2, but I kind of see Lido personally as like a three-phase project, if you will. The first phase was launching liquid staking for the masses. The second phase is widening the breadth of the protocol to include as many independent node operators as possible. And the third phase is finalizing and ossifying this protocol as much as possible in a way that is both robust from a governance perspective, but also as immutable as possible from an on-chain code perspective, and creating a market basically of validators and node operators that compete in a secure and decentralized manner to offer the best possible capital efficient reward base for stakers, and at the same time securing the network. So the staking router is kind of the infrastructure that will underpin this evolution from a somewhat limited curated operator set, which is how Lido v1 currently functions, into something that will allow other third parties, for example, or even Lido contributors, or even infrastructure providers for things like validators, which is basically how we see like Obol and other DVT providers, that to offer their way of like onboarding additional operators to Lido. So we envisage modules being created that will basically dock into the staking router, kind of like in a plugin manner, and that these plugins will afford all of these different module creators different ways to interact with the Lido protocol, make staked ETH available to users in different ways, and offer kind of like competitive advantage compared to each other in order to vie for increasing stake in the most effective manner possible.
That is massive. Thank you so much. And I also have to thank you, because this update that you're sharing is like the perfect path for us to make a brief comment on the work that the research team is doing. So as Izzy was mentioning, and as Lido is moving towards different sets and different kinds of distributed validators, part of the research that we have been doing with the Lido DAO is to help them devise a mechanism that would allow permissionless operators. That is like, this could be like not companies or organizations, but like small players who want to like stake with or be node operators for Lido, and do so via some kind of reputation mechanism or some kind of identity mechanism that allows them to participate without having to post, for example, as much collateral and suffer from capital efficiency loss. So we have been working with Lido to achieve this goal, and we're looking forward to continuing these contributions in the upcoming months. And with the introduction of liquid staking withdrawals and withdrawals in general, we would hope that this could also make the proposition of staking or becoming node operators even more interesting for parties that are not necessarily like institutional stakers or like very large operators. And we would hope that the interest in people becoming or staking through the native mechanisms or through liquid staking in general, we would hope this interest would go up. And we are looking forward to being part of this transition as well, with the work we're doing with the research team.
Thank you, Jorge. So because the time is running, so we have 15 minutes to the actual event of the night. I would like to maybe focus now on the live data and commentary on the market's expectations to the level that everyone has to understand that that we talk about the live data about trading. There are always some limitations of what will be disclosed, but we can look at like very generally about what traders are looking at, what's where markets looking at, what markets are interested in. And then after the event, maybe during the event, we'll pay attention to if everything is fine with our core devs commenting on is it fine or not, and then talk a bit about next chapter of the institutional staking. Will it change much that market for institutions? Will they be more likely to join the staking with Ethereum? Will they be, for some reasons, a bit more apprehensive of this? So please stay with us after the transition, after Shapella. For now, I'll ask maybe Drew van der Werff and Sai Nimmagadda from Brevan Howard Digital to provide some commentary on the markets, on the financial aspects of the merge, probably on MEV, whatever you find most relevant.
Yeah, awesome. And thanks for putting this together. Great to be part of this. Yeah, I think from my own perspective, the things we've been looking at is, it's a bit quantitative and a bit qualitative. So there's a mix of like all the projections, what I'll call the street is providing. So all the firms that are out there, all the crypto Twitter, everyone's putting their views out there of, on the unlock, what are the flows that are going to be sold? So that's kind of like the qualitative aspects. And then using tools like what Metrika has put together to try to track addresses. Then even from there, once the ETH is unlocked, if it's flowing from a validator address to the exchange, like trying to understand like the actual on-chain analytics to, people have made projections about how many ETH are going to be sold. Like, can you actually track that in real time as it enters the order books across the market? So it'd be quite interesting. But the other dynamic here is very qualitative is, each firm kind of has its own process of when they'll allow you to actually unstake your ETH. And we just heard from Lido, there's, time period of when those won't be unlocked. Then you have other idiosyncratic things like the Kraken event that took place, Celsius, not sure how much FTX had staked, if they did, even Binance with this, the regulatory things that are going on there. So there's all these things that'll happen and shift that are semi-idiosyncratic to even just anyone selling or anything like that, just the movement that'll cause noise. So, the problem here is in traditional markets, they generally don't repeat, but they do rhyme in most cases. There's not a lot of things you could rhyme Shapella off of. There's not a lot of analogies you can draw on. So a lot of people are just keen to watch the events that are taking place around that. And I know, Mara and others will talk about the institutional side of things, but do see this as a de-risking event. And you think about someone like Brevan or any really hedge fund out there. If you went to your risk manager and said, "Hey, I'm going to earn 7% yield on my ETH, but I don't know when I'll ever get it back." It's just a difficult conversation. You could say things, "Oh, there's liquid staking," but you're adding another level of complexity and already like maybe an unknown complex situation. So post the upgrade, it's just a bit easier to say, "Hey, I'm going to lock up my ETH. I can get it out, earning some yield for acting." So it'd be quite interesting. And then post the upgrade too, quite excited to see if a lot of ETH does come in and there's more deposits than withdrawals and institutions get comfortable, just discussions around any validator caps. There's been things around single slot finality, people talking about the economics and wanting ETH to be out there and that, Ethereum may not reach, 60, 70% of the network stake, things like that. It'll be quite interesting around the staking environment, more broadly, but also just the dynamics of the staking industry and what that means for liquid staking and things like that. But do anticipate taking time for folks. If you aren't staking today, you're probably not aping in tomorrow, even post upgrade. So these things will be interesting. I think we have Sai on the line too, as analyst on our team, and we've been watching some interesting data around that. And so I don't know if you want to quickly comment, and then we can transition to others.
Just to add on to what Drew has mentioned, we're obviously looking across a lot of data across different chains. Tracking deposits, withdrawals, the kind of accounts or wallets that are interacting with staking, and just client diversity in general. And if people are shifting from liquid staking more from staking in general, we're also looking at a lot of on-chain dynamics and seeing if any of these withdrawals can be tracked to particular entities, and if there are some of them if they are exchanges. Really curious to see the data that it's available post the upgrade and all the benchmarks that will be created. It's really curious to see how all of this would unfold.
Thank you so much. So maybe let's look at the data. Bassett, I believe that you have the overview of all the dashboards, and now with 8 minutes till the upgrade, would be great to once again remind everyone who is tuning in on YouTube what those links are, how they can observe the upgrade happening, and what those different metrics mean. So Bassett and Tomasz, I believe it's our team at DeFi Research, if you could share all of this and talk a bit about it, and maybe share the screen.
Yes, we've got
let me share
and
the
Harsh,
screen.
so they will take over right now.
Oh, do you want to share, Harsh?
You can start with Bassett.
Okay. Okay, so I want to make sure you're seeing the correct screen.
Yeah, we're seeing the Black Diamond screen, but we see our entire desktop, so we see also something in the background.
Yeah, that's not perfect. Having the responsibility of looking at so many dashboards, I have way too many open now. Trying to, let me just go through something else first, which I wanted to mention. So we actually at Nethermind, or the DeFi research team, we're working on an article called The 10 Things to Watch Once Shapella Goes Live, and it actually includes most of the data sources. And what I think it'll be interesting if you're watching live right now, now and leading up to the upgrade, and in the coming days and weeks, it'll be interesting to keep track of these things. So first of all, obviously the exit and activation queues, we talked about that a little bit. I mean, it's available on Metrika and on the block daemon. And so basically, I mean, it's important because we want to see the dynamic. I mean, there was some speculation, obviously, that many withdrawals will take place, but we see currently that there are more activations than withdrawals. I mean, and also we know that many liquid staking protocols are incentivizing solo stakers to migrate without withdrawing. So keeping track of these queues will be important, both the exit and activation queues. As we talked about, the BLS withdrawal credentials are also important. I mean, there can be no withdrawals unless the credentials the validators switch to the proper credentials. And you can keep
what are
track
the
of that
actual
on
numbers on every single metric that you're mentioning now? What are the exact numbers now and what they mean? Like, are they as expected, or? We have 6 minutes to go, so we care about the actual numbers as they're happening live. So let's look at every single of those metrics and explain to our listeners what it means. Where are we?
Yeah, I'm having some issues sharing though. That's the only problem.
Harsh, can you share?
Yep. Can you just confirm if you can see the screen now?
Yes.
Yes, can see the screen. Thank you.
Sure. So we can see the queue right now, and the queue activation queue right now is standing at 129 versus the exit queue length is at 86. Another interesting point was that, as Andrew mentioned, that for Kraken, they will be withdrawing for all the US customers, and around 3% of all the withdrawals were from Kraken. So that amounts to around 4,400 ETH. And we can expect that going into some other protocol, or either that would be a centralized staking, or it would be a decentralized staking application. So that is something that would be interesting to see where those ETH that are being withdrawn by Kraken actually goes towards. Along with this, there is another interesting thing that is happening is with the yield of all the liquid staking tokens. So a lot of liquid staking tokens, there are a lot of organizations that are coming out with additional strategies, and what they want to do is they want to capture the MEV between the LST tokens as well as ETH in order to increase the yield. So as we move forward, we'll see how the circulating supply of ETH is changing, and it was previously around negative 22 to 21,000, and right now we have 19,850. So the circulating supply is actually increasing right here, and we'll see all these balances increase, all of the data update properly once the Shapella upgrade actually goes online. So the withdrawals per block will also be updating soon. Busa, do you have anything else that you would like to add?
Another thing that we discussed was the transition basically away from wrapped ETH. I think this was a popular narrative in the DeFi space as well, that I mean, if you go on Aave, for example, the lending protocol, we see that there was some kind of an arbitrage because the yield from staking was much higher than borrowing for wrapped ETH. But we as a team expect that arbitrage to go away in the future. And we're also, not only us, this was raised in the community as well, question the idea of using wrapped ETH when users can stake, especially in an environment where the borrowing rates for wrapped ETH are so much lower. It just does not make economic sense, and we think it's another driver for the growth of liquid staking as well. And just to mention one more thing is the withdrawals that will occur very soon, actually, because of the Kraken US issues with the SEC. We expect.
Stop you here because we have 1 minute to go, and I would love now everyone to focus on the actual live data and the things sticking. So maybe for a core team or Pari, if Pari is even looking here on the call, I think he's observing somewhere else. So I want to chase him. Let's look, like 1 minute to go. 1 minute to go. We're observing the slots. I believe that we can share this like beacon chain slots. We can look at the 26 seconds to go according to the website Bordel WTF from the team in Prague, I believe. Marek, how does it look?
For now, I'm just observing many nodes and waiting for it happen, and basically waiting few seconds for next block.
Can we share the links with?
I can share my screen with the slots to visualize the fork.
David Ahmad.
Go ahead.
I'm not entirely sure how to share.
Okay,
maybe I
can share. Okay.
Okay.
So this is how my screen looks like right now. So I have a Lighthouse node here, a Teku node. There is interesting tool. Oh, and we hit the hard fork, and we can check fork monitor, and it looks like 41 seconds ago. Maybe it's not updated. My node is progressing. Yeah, all pairs are working fine, just fine. Just to explain this UI. So if we got to the fork, we will have red color here. And basically it means that all different client combination agreed. And we see that Lighthouse is also working. Nethermind Teku is progressing, checking our archive node, and it's also returning valid, so it looks good. And what's more, let me check.
We're missing a lot of slots, Marek. Can you check the visualizer?
we are missing, you mean that
this one. Sent it
slots?
on the chat.
Okay. On Block Explorer.
Oh, on Beacon Chain.
Beacon Chain Block Explorer.
Beacon
yes.
Chain, yeah, Beacon Chain.
So
no. You can go to dashboards, and dashboards you can, I think, go to the visualizer.
Did we just miss 5 out of last 8?
Looks like it.
1, 2, 3,
All right.
4, 5.
So what we see for now is that just after the transition, some blocks were not proposed, and this is at the stage of like around 50-60% of missed. But now it's becoming a bit more green. So it might have been something temporary. Let's keep observing.
I need to check sync aggregation because it is important metric, and it is fine, I guess. Okay, we missed a few slots, but probably some of the validators weren't upgraded. But 90% sync aggregation is very good after the fork, in my opinion. So
okay, so you have core team assessing, that looks good. And now I would like to ask about what we see about the MEV levels and the block payments.
Also, we can see withdrawals coming in Etherscan.
And I think it's also in this Block Explorer. Okay, maybe I will stop sharing screen.
Most of the withdrawals I'm seeing are just reward withdrawals. Haven't seen a full exit withdrawal till now.
Okay, when we say that we have the withdrawals, so far nobody who exited fully has withdrawn the full amount, right? So we see only the withdrawals on top of 32 ETH. For those who are staying on the network, we'll be waiting for the first withdrawal of like 34 ETH probably at most. And how about MEV payments, Thomas? Does your team look at the payments rewards? Can we share, like, were there any heavy blocks, very valuable blocks just after the transition? What do we see on the volatility side?
Basad, let me check in right now.
Checking also.
Okay, let's give the device some time, and so far we still can confirm that everything looks good. We see still some missing blocks, like, so I've seen in the last 20 blocks something like last 20 slots, three blocks are missing. Yeah, Ahmad, exactly this. So you see this red squares. So these are missed blocks. It's not a problem for the network in general. We are mostly green, and the clients are progressing, and everyone is in sync and testing. And do we have the finalized epoch now?
Not yet, not yet finalized. But if you look at the withdrawals, most of them are 3, 2, so they're just rewards. Till now, we haven't seen a full exit.
But we need 12 minutes, I guess, to finalize. So it's normal situation.
Yep. We need to finish this epoch and the one after it, and then
yes, 2 epochs.
Sure that it finalized.
Okay, so this is what all of us are waiting for, the finalization post any fork, saying that everything looks good and the attestation and time progressing and agreement of the network. No chain splits so far. I don't know if you have any like visible tweets that we want to share here with our listeners, if there's anything that that is happening in the community.
I'm just tweeting that.
We see Terence from Prism saying probably that everything is good. Closes the loop of the original beacon chain design. Exactly. So what we mentioned at the beginning, but that practically this closes the proof of stake transition. Not only it allows the beacon chain and the execution layer to work together, but also finally connects the ETH that was deposited on Ethereum to initially on Ethereum on the beacon chain, connects it with the execution layer, and we can go both ways now. So staking and unstaking is now possible, which means that it opens really a new chapter for the for Ethereum or for the markets. And while waiting for the confirmation for the finalization, let's start to talk about this new chapter. And I mentioned that I would love to discuss the notion of the institutional staking and what this change means for institutional staking, what kind of market we expect over the next 6-12 months, and maybe even like years to come. Like, will Ethereum grow as this like fixed income asset and something for the institutional institutions, traditional finance to always look at. And we have here great guests to discuss this topic. We have representation from Alluvial, which is liquid staking for institutions. We have representation for TwinStake, institutional staking, KYC focused operator. The regulated operator, and Andrew here, and we have Mara, and I believe we wanted to cover this topic. Yes, please start, because I'm thinking about too many things. Andrew, maybe you'd like to do a bit of intro of your view on the market, and then Mara, if you're still with us, Matt from Alluvial, if you'd like to add and comment on Alluvial, would be great.
Yeah, I'll go. Absolutely. See, glad it's going well, because this is a big thing for institutions in the space. I think Drew mentioned there's been like real hesitation amongst institutions to stake ETH without knowing the kind of when they're able to withdraw those, withdraw their staked ETH. I think this is a kind of game changer in that respect. We've been having constant conversations with clients who have been relatively risk off up until certainly the announcement of Shapella, and the conversations are becoming much more pointed as we've gotten closer to this date. And what I think we'll see is that we might get some short-term volatility. It's going to be super interesting to see that withdrawal queue, because I know we spoke earlier about both the activation queue and the withdrawal queue and how those will interplay in terms of the kind of underlying price action of ETH. But it's going to be super interesting to see the size of the withdrawal queue. And that's kind of the conversations we've been having with institutions in the space. So I think we might see some kind of short-term volatility there, but certainly in the long term, this is a big moment for staking, and in particular institutional staking. I think this kind of clarity and crystallization of the staking methodology will really help drive volume, and it'll help drive the staking ratio up to kind of more comparable levels that we see in other L1s.
Thank you, Drew. And Matt, Mara, how it looks for Alluvial, what new markets starting?
Yeah, maybe I can get us started. So one of the things that we observed as sort of not just the staking market has matured, but also adoption and liquid staking has picked up is, the interest and appetite of new participants to enter into the market, to get access to new product utilities and capabilities. And liquid staking, of course, unlocks a lot of that. At Alluvial and through Liquid Collective Protocol, we're focused on building out an enterprise-grade protocol standard so that leading custodians, exchanges, fintechs, MPC providers in the space can easily integrate liquid staking to offer it to their customers. So one of the things that, of course, especially now with the upgrade completed, I think one of the things that we'll see is a lot of interest emerging from a lot of the stake that has been on the sidelines, particularly on the institutional side. I think sort of the unknown withdrawal period has been one of the major unknowns for staking participation from that market segment today. And I think we'll see not just appetite in participating in traditional staking, but in particular in liquid staking solutions that unlock a whole lot of new use cases. So direct participation, being able to leverage liquid staking tokens to enable trading strategies, including market neutral trading positions and other capabilities and use cases that we're going to start seeing emerge. And we're super duper excited. But maybe with that, hand it over to you, Matt, for a little bit more on that.
Yeah, absolutely. So, yeah, so as Mara mentioned, I think, one of the things we're super excited about is really what this opens up in terms of liquidity to be able to implement some of these trading strategies you mentioned. Funds have mandates that they can't have an indefinite lockup. And so, I think this is going to be a huge boon to volumes here. And so I think we're going to see specifically with a lot of trading opportunities and, deeper liquidity right now. If you're a market maker on a secondary market for a liquid staking token, you can't really manage your inventory. You can only go in one way. You can create more of the receipt token. And so now I think we're in a space where certainly they're able to manage their inventories. And so I think that's going to support a ton of trading opportunities, not only in the structured product space, but also in the segment ETPs and the likes of others where staking really isn't a part of those products yet, but I think that this will allow that to come to fruition. So I think there's a ton of demand that we're going to see come into the market soon. So really excited to see what happens here.
Thank you, Matt. And James, you've worked a lot with institutional clients. You can see what their expectations are, what questions they're asking, what they were waiting for. I'd love to hear your view here.
Thanks, Thomas. To be honest, I'd echo a lot of the things that have been said before by Andrew, Mara, and Matthew. Institutions have been waiting for this for a while. In fact, a lot of the clients that we speak to have been reluctant to lock up funds without kind of a clear withdrawal option. Liquid staking and the like have obviously provided some of that kind of bridge. And going forward, institutions are clearly going to be entering this space. In terms of timeline, it's anyone's guess when that will be. But from the conversations that we tend to have, it's looking towards at least the back end of this year. I think when people start to have these conversations, and at least moving towards the discussions internally. Compliance and risk with a number of the kind of traditional asset managers, hedge funds, are a big part of those conversations. And the fact that now you have a clear withdrawal option and the fact that you can stake and unstake is incredibly important to these places.
Thank you, James. So definitely the institutional market, something to watch. So institutions will be moving a significant number of validators on and off chain. There are some predictions on what exactly staking levels will be. And before we talk about that, Shapella finalized from Ahmad. So that's what I hear, which means that we can celebrate even more. We have finalized the epoch after the Shapella transition. So everything looks fine. It's another non-event to some extent after the merge. Maybe possibly I'm waiting for the first coverage where we will be able to show the real-time fixing of things. But it seems that maybe, okay, the question is, do we have still the testers and fixer and infra people on the call? Possibly not. It's like, do we have Pari here? No, understood. And do we have Yeah, okay, they're all checking if everything goes right. I mean, there might be some other processes, some other tools that are running in the background. I'd love to confirm if everything looks good with the relays and the block builders. Let's look maybe at some of the metrics related to the relays, to what's happening now. If we can share, maybe please the data team, if we can share some of our best MEV trackers, as while I'm talking, it's a bit harder for me to find the things, but maybe the one conversation I would love to hear is about the expectations of what would be the cap or no cap, and what will be the amount of ETH staked. So it's hoping that we will have Justin here that talks now a lot about the things related to MEV burn, about MEV smoothing, about the cap. There were some amazing articles being published recently on our way to things like single slot finality, the cap on the validator amount. Will it be 15% as it is now? Will it be 30% immediately as some people predict? Will it be 70 or 80% as some other chains, which would be risky for the network activity? So we're starting this big conversation now in the space of protocol engineering, in the space of protocol economics. If you go to maybe to ETH research channels, let me see what I should send as a link. Probably ETH research category economics is something to look at over the next few weeks or a few months even. Like, we'll be talking about the validator cap, and I'll also share with everyone this roads to single slot finality article, which will be the important path towards single slot finality. So this is from Vitalik from 6 months ago. I'm sharing that with everyone as well. Look at this as the background for the conversations that will be happening. Also pretty interesting piece that appeared recently, which is all revolving around this conversation of what the end game for staking for MEV is. Like, who is producing the block, who is relaying the blocks, how the network looks, do we enshrine PBS, what will be the staking levels, what will be the participation of solo stakers? Because when we talk about the decentralization on the network, we care a lot about the solo stakers participation. We care a lot about solo stakers having equal rights and equal benefits from participation in MEV. People say nothing exciting on MEV, which may suggest that there is not that much volatility. By nothing exciting, I imagine that people say that no block builders are reporting being broken, no MEV boost problems, no relays unoperational, no blocks with some massive payouts. So this would be, wow, potentially less of an event than we expected. So here is this like endgame perils of restaking article that I share with everyone on YouTube as well. And then the concepts of MEV burn, MEV smoothing. Look at this one. What is next as well? So the other thing we'll be talking about 4844 and data availability. So maybe if we get our core team to discuss a bit about the next forks, what coming after Shapella, what improvements, and maybe also now, since we have a bit more time, looking at what other changes came with Shapella. So we focused on withdrawals entirely, but what are the other EIPs that went live and how they will change the lives of the dApp developers? There'll be some gas savings for sure with Push Zero. Yeah, please.
Okay, so I can cover that, I guess. So the main Shapella EIP was, of course, withdrawals, but besides that, we had a few small EVM EIPs, and one of them is Push Zero, which give us some gas savings. And what's more, we have a warm-up Coinbase. And again, it is about a small change, but with with gas savings. And one more EIP was 3860, and this EIP is prerequisite to big EOF. So it was preparation for the next big changes in EVM. And what is interesting, we added one more EIP that doesn't require any code changes, which is self-destruct. And basically, core devs want to communicate to people that, hey, we are gonna deprecate self-destruct, and that's it. But we haven't changed it, any code based on that, and we will remove self-destruct in one of the upcoming hard fork. And what next in Ethereum? Of course, for 844, it will be for sure included in Cancun hard fork, but there is lots of work on EOF stuff. EOF will be very big changes in EVM itself. I think there wasn't such big upgrade of EVM on any hard fork. And what else? As Pari mentioned during our coverage of testing, we are also preparing vertical trees, but I personally expect that it will take more time to deliver vertical trees, but EOF and for 844 should be delivered in next or one of the next hard fork.
I think one of the things that is worth mentioning here is that there is the community right now and the core devs are leaning toward implementing a change to how self-destruct works. And this change is not just deprecating self-destruct and making it send all, where it doesn't actually destroy the contract, but allowing self-destruct only when a create to instruction is proceeds it to replace the self-destructed contract. And you can see the details on EIP 6780 or 6780. And of course, we want all the feedback that we can get from the community, especially from smart contract developers, to see if this satisfies most of their workflows in the smart contracts, and that if it is done in this way, it will not break their smart contracts, how their smart contracts work. I just thought that it's worth mentioning because we're still looking into the best way to deprecate self-destruct, because like self-destruct is one of the blockers to vertical trees. And if we want vertical trees to go in, we need that to go.
Oh, and we also have small changes in engine API added in Shanghai. So one of them is to mitigate censorship. And one more thing was very technical. It's about how CL is downloading blocks from EL. Yeah, so it's not worth mentioning, I would say, for smart contract developers. And I sent the link which described Shanghai specification with all EIP listed. And basically in this repo, we can find all Ethereum upgrades with a list of EIPs.
Thank you. And so we have one guest that we didn't ask for a commentary, but might be a good time to think about the security of the network going forwards, like what we have to look at in the security space. I'm not sure, Justin, if you're still actively with us or you're in the background, but if you'd like to share of how you feel about the security of the network now, how you think about the economical aspects of it, cryptographical aspects of it, and do we have Justin with us? Possibly not. Okay. And let me check. Trying to look. Oh, okay. We have also Lion from Gnosis, and this will be great because we look at Gnosis chain. Well, maybe first I ask if Lion is actually actively with us. Lion?
Yes, I'm here.
Okay, perfect. So just for everyone who's listening, since we're changing the time, this is like 4 hours call. Guests are coming and going, so I need to double check if we have them with us. So Lion's been working a lot with Gnosis Chain recently. Our team was working with Gnosis Chain in preparation for all the like replication of many of the concepts from the Ethereum mainnet. So Gnosis Chain is that one chain that runs with the similar model, same model of the staking of the validators, and is preparing its own set of upgrades and updates. So maybe Lion and Daniel on our side from Nethermind, if you could discuss a bit about the roadmap of Gnosis and how these changes affect Gnosis economics.
Sure. So, so far we're tracking the Ethereum roadmap very closely. I think what we can talk about is what's coming next. So the Shapella 4 will come almost quasi-identical. On the execution side, we're going to merge same set of EAPs. For consensus, it's going to look like quasi-identical. But the peculiarity is that because the execution side of Gnosis is XDAI, the token cannot be inflated. So in Ethereum, the base token you pay with gas is ETH, and you stake with ETH. But in Gnosis, you stake with GNO, and you pay gas with XDAI. So the withdrawal logic is a bit different, where instead of minting the native token, you just release the original staking token plus reward that will be paid out from the DAO.
Daniel, do we have you with us at the moment?
Yes, you woke me up.
So we're talking now about the roadmaps. So you work with all our core teams. You know which different streams of work we have. You worked with Gnosis. You look at vertical trace. What's your view on the next big things and where people will be refocusing? All that workforce that was focused on Shapella, where there'll be the most active world.
So like from Nethermind perspective and the core team, I think that the biggest focus now will be on 4844, and I think there will be not just us, but in the whole community, that will be the main thing, the next big thing. And as far as I know, it has been already agreed to have it in the next fork. And what more we will squeeze into the next fork, I'm not sure, depending how it's gonna go with 4844, because we don't want to postpone it too much, because even from Vitalik, he said many times that what is important to speed up the work that we do for scaling Ethereum and to decrease the gas cost, etc., etc. And this is important. This is important for adoption. And so I think recently he mentioned that like vertical trees are important, for example, but they can wait if you compare it to 844. So I think 844 is next. There have been a lot of work, like Marek said, on EOF, so that's also probably probably gonna be included in the next hard fork. And yeah, we're still working on Werker trees. There is not Tanish with us, who is our developer on Werker trees, but Nethermind also participated in the last test chain. I think Guess and Nethermind were the only execution clients that actually were able to join the test network. Yeah, so that's the next thing, the next big things. Yeah, so I think like scaling is probably the biggest focus at the moment, just after Shapella.
All right, thank you. I feel that we also clearly enter into the rollups world, or we have already entered, but I think that transition happens, and Shapella is one part of it. Why is it? Because it's bringing us closer to the discussions on 4844 and data availability. Also because we start talking about the economics of staking, and we see more and more ideas built on top of what happens in the space of like what validators, what proposers can do, right? So I see a lot of designs related to the attestation committees, like sync committees, subcommittees on the subset of proposers participating in some roles related to sequencing, to MEV burn, MEV smoothing, and so on. So we're talking about bringing the expected rewards to be much less volatile. So what happens nowadays is that if we have one block that pays out 500 ETH rewards, this is very uneven distribution. We'd like to see some smoothing. Some smoothing happens maybe automatically on the operators within the liquid staking solutions, because those rewards are distributed among all the participants. But where we have solo stakers, those rewards can be like very unexpected, very like we can see we can see very unsmooth results, and this is not best for the network, not the best for the network security, not best for predicting the payment for security of the network. So now when we talk about participation of proposers in sequencing, it means that we start opening discussions about things like based rollups. So this is something that I'll try to quickly find a link for everyone. Some discussion from Justin on based rollups, and discussion about how Ethereum can participate in sequencing blocks on layer 2. Then there are many projects appearing with the shared sequencer solutions where the sequencing happens outside of the network. Data availability, the enshrined rollups, the various rollup solutions, the current what's happening. We see the liquidity flowing to the rollups, and I think that also a super important thing that I encourage everyone to look at is eigenlayer entry staking, and next to the attestation committees, the restaking may open a lot of innovation, especially now after Shapella. And here maybe Swapnil and Yorick, who work a lot on those topics, Swapnil particularly a lot on eigenlayer recently. If you could cover that scenario and discuss what happens, what innovation will happen on staking, we'd love to hear from you.
Yeah, I just said restaking is basically a new primitive on Ethereum. It opens up a whole new space of design and solutions to do. By the way, is my audio fine?
It's great, yeah.
Yeah, so some of the ideas that we're seeing in like a rollups as a service, where we see the influence of app chains, but maybe you don't want to spin up a new own trust network for your own app chain. So you want to just spin up your own rollup. You want to settle on Ethereum. There's many startups working in this space. We have like Rollkit, we have Stacker, and a few more of the solutions in the space. Then there's a lot of bridges that are leveraging this shared network trust that they can gain from Ethereum.
Swapnil, can you explain a little bit more of the basics of restaking and what it looks like, and then go to the applications?
Cool. So as the name suggests, you stake again. And in this case, what you are staking is your stake in Ethereum itself. How it works is you have your withdrawal credentials, you transfer your withdrawal credentials to some smart contract managed by, in this case, EigenLayer. And now you can do some bookkeeping in the smart contract, which can manage slashing and whatnot in the smart contract. And when you try to withdraw, finally, it would apply these slashings, and you would only get the part that the unslashed part of your restaked ETH. What this gains us now is that we have derived economic security from our stake ETH for some other new trust network. So in the case of rollup as a service, we can spin up a new rollup, and we can require that the validators of this new rollup or the sequencers of this new rollup have some staked ETH already, and only they can join the network. And to join the network, they have to risk or restake the ETH, i.e. also deriving security from ETH. The incentives for them are quite nice, because if they're an honest node, then they have just one more opportunity to make more yield on an investment that they already made by investing in ETH. So for them and the operational cost of running like a proof of stake network is quite low. So for them, this is just one more additional place for them to yield. So I expect a lot of institutional services, once the risk reward modeling of these new middle layers is settled down, for them, this is just pure, well, maybe not just pure gain, but yeah, with very well understood risk, with no additional investment, more gains to be made. And there's very interesting models in here where some middlewares might reward you in ETH itself, depending on how the network is. Maybe they're collecting fees in ETH. Some new tokens can spin up where you might be required to restake ETH for the security of the network, but you can pay rewards in your own new token. Very useful for like rollups as a service. Yeah, any more questions?
Yeah, so can you go through maybe some of the basic like applications of this? So you have a rollup that uses the same security layer. Are there any other applications that would be useful here?
Yeah, so there's maybe I'll take some names as well, give some shout outs. There's a professor who's doing shared sequencing. So they want to do sequencing for multiple rollups through this shared layer. Also, an interesting point to mention is that if you've read EigenLayer's white paper, they also mentioned that you can have like double quorums. So you can require your validators that they restake ETH, but you can also require that they also stake your own token. So if you're a new network and you want to start up your own economy, then you can derive some nice base security from ETH, but also start up your own economy by requiring that your validators stake this your own new token. Yeah, so touching on other use cases, there's rollups, there's bridges, and realistically, there's any like actively validated system. So things that vaguely look like a blockchain, have some sort of network. Those are opportunities for innovation to be done here. There's also like data availability services. Yeah.
Yeah, there's a few. So this changes the dynamics a little bit, right? So maybe we can explore this. What does it mean to share your security? Does it introduce any risks into the network compared to what there was before? Like how far do those risks go? And also there's like a small influence that it has on the fact that you can also introduce rules to Ethereum, for example, through staking, through restaking. So these are some like interesting areas to go through. So if you could break those down, that'd be cool.
Cool. So kind of broadly, just basically touching on how does restaking affect the staking of ETH itself? And some concerns to present here first maybe are like, let's say that there's a new middleware which is amazing and it gives like 1000% yield somehow, but also requires intensive computation. So it kind of skews or pushes solo stakers out of this equation because it requires a lot of computation, requires big hardware, big setups. And it might be a case that the solo stakers sell their stake to like some bigger institutional stakers so they can run their services, they can make more yield. Maybe there's some private deals about where they will share some yield. So there's some centralization risks there. And I know that the EigenLayer team is thinking about this, and they are working with teams to make sure that the middlewares are lightweight so that the solo stakers are not pushed out of this equation. But on the flip side, there's also a positive pressure to stake more, because earlier when you stake, you let's say have 5% yield on your ETH, but now you have possibly many more opportunities to gain yield by just staking your 32 ETH. Yeah.
Having positive pressures also like adds some other risks because there's an interesting paper which discusses the various effects of this. I'm going to let someone link it into the YouTube, where you actually don't want all of the ETH staked into the security layer of Ethereum. You want to have some of it liquid, as far as I understand. Oh, well, that's my opinion. And there are some fine balances in the economics of Ethereum to try and keep these numbers stable. And the restaking can skew these, so there needs to be some consideration about how to integrate this in a positive way. Great, we might hand it back to Tomasz if he has any more, or Swapnil. Yeah.
Interesting cases to add on EigenLayer. So we've discussed middleware's new networks, but what we haven't discussed is how EigenLayer can change the consensus of Ethereum itself, or can be like a testing playground for doing changes to Ethereum itself. So slightly digression, but EigenDA, which is like a data availability layer, is using the mathematical primitives from proto-tank sharding, but we don't have to wait for a hard fork or like for Cancun. Well, EigenDA will probably release after Cancun, but theoretically, we don't have to wait till Cancun to see like proto-tank sharding in effect. We can have it already in EigenDA or some other middleware which also implements it. Additionally, we could also, like, if assuming that 100% of the Ethereum stakers restake into new middleware, we can impose new consensus conditions on them. So we can change the consensus protocol of Ethereum, or add new conditions on consensus of Ethereum itself without doing a hard fork of the network, which is also a great thing because now we can have like opt-in solutions for these kind of things. So certain validators of Ethereum could opt in for like providing an amazing data availability service because they have huge hard disks or they have a special hardware for it. Certain validators of Ethereum could like do really fast sequencing. Certain Ethereum validators could do some other kind of service. So kind of takes us to like a very modular Ethereum with a opt-in system. And for like from the institutional investment perspective, also opens up a very like heterogeneous portfolio. Right now, if you're staking, you have a very homogeneous kind of choice. The risk reward balance are there's only so many cases because building up a new network is hard. With middlewares and with EigenLayer, you can build up new networks with different risk reward profiles, and you can choose and kind of Lego your way into it. Yeah, handing it back to Tomasz. Do you have anything to add to it?
Thank you. A lot, but I think that over the next few months we'll be spanning out from that. As I say, I shared a lot of links on our YouTube channel, so have a look. There's lots of exploration, probably maybe 60 hours of reading about all the novelties that can be based on restaking, on the in the world of single sort finality exploration, the staking cap, and also the attestation committees, MEV Born, MEV smoothing, reminding all of this. Also the order flow sharing, the solutions like MEV share from Flashpots, the innovation to the proposer builder separation with enshrined PBS, so the PBS without the relay role, with everything running on chain. Thank you for all the guests that had probably to sleep but joined us. Thank you so much for commentary. And for those who stay, I think I would like to share some data updates of what we're observing. Maybe if Mariana, if you're still there with us, I see you, but I can understand that you may be overseeing data and the team at the team work. So happy to hear from you. What do you see? What we can tell about the network?
Yes, we are, but I think everything is working smoothly right now, it seems. I think there was a bit of a drop in the participation rate, but that was kind of expected. And everything
How about the queues? How about the withdrawal, exit, and activation queues?
Toran, are you on top of that?
I see.
Yeah, we haven't. We've seen a few more exits, 9 exits since the upgrade, but nothing significant there. the activations are still being processed. We've seen the credential changes come through. I think there being so many credential changes right at the upgrade is probably what caused us to miss some of those blocks. But yeah, other than that, everything seems to be coming through, mainly partial withdrawals so far. All of the blocks are being filled, 16 withdrawals per block. Yeah, it seems to be running smoothly.
Amazing, thank you. So this is, I have to say that I'm surprised. I expected some more activity on the exits and on the activations. But maybe all the stakers institutions are actually observing the queue length and they don't want to enter into a very long queue where they actually force themselves to participate in like long waiting, no ability to decide on the go. All right, and on the EigenPhi side, I don't know, Brian, if we have you with us still, and if you could maybe make some comments on the numbers that you see on MEV?
Yeah, still there's no like expected fluctuation in terms of volatility. So I think still so far so good. And yeah, I mean, yeah, and we have an article that kind of analyzed the whole event of the Shapella upgrade, and we anticipate that there's going to be more rewards from LSD related tokens and this kind of stuff. And yeah, basically that's kind of our current idea.
Perfect, thank you, Brian. And I was checking also on the Flashbots channels. It seems that everything looks good, no problems that we've noticed. All the relays builders seem to be operational. We'll be seeing over the next days if anything changes. And I see that we have Sreeram with us. So we covered EigenLayer a bit on our side, but did we just lose Sreeram? No.
No.
Oh, yes, we have. Thank you, Sreeram. It's great to see you. So you're leading the EigenLayer team vision, and we covered it a bit. We think that EigenLayer does define a lot of the future of Ethereum, of staking. A lot of innovation will drive a lot of innovation to the field, and would love to hear from you of what you see now after Shapella. What does it change for EigenLayer? Do you think like the chapter has been closed, a new chapter begins?
Yeah, thank you so much. It was great to see a lot of our collaborators here, Swapnil and and others. Thank you so much for the opportunity to come and participate in this. It was a super exciting day today to be here and witness this. I think full launch of staking with Shapella. So really excited. I still remember the time when we started our project, and many VCs and others are like, "Oh, how much is the risk? That the merge happens successfully?" And I'd say the merge is completed today. So from our viewpoint, I think just to give a sense to people who may not be familiar with EigenLayer briefly. EigenLayer is a mechanism for Ethereum staking to supply security to any services that want to build on top of this same staking security. And the mechanism by which it works is there are really two different mechanisms which lead to the same kind of output. One is called native restaking, which is if you are a home staker, institutional staker, anything, you just normally you would set the withdrawal credentials to an execution layer address of yourself, your own wallet. Instead, you set it to the EigenLayer contracts, and in the EigenLayer contracts, you set the withdrawal address to yourself. So it's just adding a step in your withdrawal workflow. So that we call native restaking. There's another approach we call liquid restaking, which is you can take a liquid staking token and then use that, stake the liquid staking token into EigenLayer, and then delegate it potentially to the same node operators as the liquid staking token or to a potentially distinct operator. But this is, I think, net effect of doing this liquid restaking is pretty similar to doing native restaking, because if you did native restaking and said, hey, this node operator said maybe Lido or somebody else is actually validating my Ethereum node, and this other group, which may be the same group or a different group, is validating my eigenlayer actions in a native restaking. Basically, to the system, it looks identical. So that's why we have these two modes. It's just for people who already participate in liquid staking, they can use the liquid restaking mode. The other one is the native restaking. And as far as what particularly Shapella enables for us is from our end right now, we are on stage 1 testnet, which allows restaking, both native and liquid restaking. And one thing is, when that goes to mainnet, stakers who had, let's say, 0x00 like BLS withdrawal credentials can just repoint it directly to the eigenlayer contracts. So that's something that we are looking forward to. The other thing that is uniquely enabled by Shapella is there's a bunch of people have new reward stake that they want to restake. There's another kind of restake, terminology conflict here, but you take the stake and then the yield that people have generated, and they bundle it into a new validator that they can deploy. And while eigenlayer is not live today, it's not possible. So if people are, some of the viewers now maybe wanting to do this, you cannot point it to eigenlayer, but what you can do is to point it to a 0-0 credentials. Thankfully it's still possible, so that you still have one-time option to switch to whichever execution layer address you want, including eigenlayer or something else. So that's an option that maybe some people might exercise.
And we've discussed a bit about the various discussions on security concerns related to the restaking. We know that the Ethereum Foundation researchers look at the staking cap and the risks to the network related to restaking. How do you assess the complexity of those conversations? How the collaboration between researchers in the network look? Is it a bit of a surprise, unexpected solution that that now requires much attention? Is it urgent? Is it less urgent?
Great question, Thomas. I think it's similar to the discovery, so to say, of MEV, let's say, right? The permissionless systems have, things that can happen that are simply unpredictable a priori. And I would say that this is something similar in nature, in the sense that you have a permissionless staking system and people will come up with ways of using it in different ways. And restaking or reusing the stake to make credible commitments, not only about how you're validating the Ethereum node, but also other things, is a kind of, I would say, somewhat unexpected. But now that it is there, this idea is that it does lead to a lot of second or third order effects that we as a community need to engage together in understanding and parsing. And it is not reasonable to say that we understand all of these effects. And it would be totally unreasonable to say that. What we want to say is that we want to engage close together with the broader Ethereum community, whether that is EF, node teams, node operators, builders, layer 2s, all of these, to actually understand an MEV, to understand how this feature, which is the stake that you're putting into Ethereum, can now be used to make other credible commitments. I think what are all the second order consequences of this? We've done our best internally, but we're starting to engage externally to get community feedback. So we're just starting to do this. And one thing we hear a lot is how much leverage is it adding to Ethereum, to other things. And I think again, it depends very much on how restaking is used, that these consequences are very different. For example, you use restaking as a collateral for DeFi, it looks very different from if you use the restake to just make validation commitments. And each of these have their own detailed rabbit holes and analysis that we need to go into. But there are definitely clear cases where it's fully understandable what restaking does. And I just give you one example, which is using it for making credible commitments on ordering transactions, right? So if you're a block proposer, you restake and then you make commitments on how you order transactions. And that's something where we can fully understand that there is a complete freedom in the Ethereum protocol for how to order transactions. But it could have very well been in another world that the Ethereum protocol has constraints in ordering transactions. And essentially, by participating in the EigenLayer protocol and restaking, you're actually expressing that freedom that actually, yes, I can now opt into a constraint on how my transactions are ordered, thus giving trust to the users, for example, that I only include encrypted transactions, I include block space. I guarantee that you're buying block space for the future. I guarantee that I will auction off only a portion of the block and still be credible about it, and so on. So I think these are very clear, simple use cases where the utility is very, very clear. But there are a lot of second order effects, which are both complex and emergent. So we clearly cannot predict a priori. And one of them that we've put some thought into is centralization risks. Like, if we build restaking in a way that everybody needs to run like 100 other chains, then clearly only like very few people will be able to do it. And whether that centralizes, Ethereum staking itself is an important worry. And we are here trying to build for the long term, and we want to have highly decentralized trust networks, because that is the market that we are in, is actually supplying decentralized trust. If there's no decentralization, there is no decentralized trust to sell. So obviously, like, we're very aligned on that. So we've thought a little bit about how to make sure that the system, and I think I want to point out one thing here, which I think is not that well appreciated. There is no incentive to decentralization today, right? Like you take the network, and if all of the validators were run by one node, it's just like better for that node, right? Not for the network. For the network, it's disastrous. But for that node, it's better because you don't have to run 500,000 nodes. You run one node and you sign off on 500,000 signatures. So and you can do more MEV things, you can do more complex things, everything, you can do a lot more, but it's just worse for the network as a whole. And so there's a lot of discussion in the Flashbots and broader EF community about MEV, and the one main goal there is how do you prevent the incentive to centralize? But there's no question on how do you add an incentive to decentralize. And I think this is equally important. In fact, this is the more powerful thing to do, is if there is an active incentive to decentralize. And I think this is something where EigenLayer can potentially play a small role, is if people who participate if services which want to recruit trust ask for only a certain decentralized validation committee, then it puts a natural incentive and a pressure and an additional yield and an incentive for more decentralized nodes to appear. So this is a second order effect, again, unexpected, but potentially positive, that we're interested in. But there are all kinds of other things, and I'm happy to talk about whichever one which is of interest here.
Right. So touching on the EigenLayer Ethereum Foundation collaboration on research collaboration, earlier we were talking about like how EigenLayer possibly enables like a modular Ethereum and like a testnet for Ethereum. Could you talk more about that, and what kind of thoughts do you have on that? What kind of services do you envision being built on EigenLayer?
Yeah, that's something that really we are excited about, is, whenever there is a new idea, right now the mechanism is we write, an EIP, and, the EIP is vetted by the community, and you try to push the EIP to the testnet. And, if all the milestones and everything are met and it gets into the, deployment priority, then basically that hits the mainnet, right? And there is a lot of frictions in this process, and necessarily so, because we're upgrading such an important and large system that touches both a lot of capital, but also a lot of users. So, and Ethereum is designed to provide like strong long-term guarantees to users. So anything breaks would be a disaster. What EigenLayer wants to play a role is as a as an opt-in framework for new ideas, right? And an example is, donk sharding, right? Like we have 4844 upcoming and donk sharding coming up later. What we've done is taken some of the cryptography and ideas from donk sharding and built a solution called EigenDA, which you could think of as like taking, elements of donk sharding and building an engineering solution around it. And this is an opt-in network that people can, run, and we can test both the cryptography out in the wild and as well as the other engineering trade-off can be explored. And, maybe EigenDA is not the best solution. There'll be somebody else will look at it and say, no, these guys have done, the architecture can be improved in 5 ways like this, and they'll create another network, which is a DA network, and launch it on EigenLayer and let like subsets of validators opt in, and maybe some rollups will opt in. And so this creates this like, basically like a permissionless upgrade path. And some of the best solutions we want and we really hope get internalized back into Ethereum, right? As we test out all these architectures, we see, oh yeah, no, this is really something highly valuable and everybody opted in and all the kinks have been tested out. Now that can then be internalized back into Ethereum. Even EigenLayer itself could potentially at some point be internalized back into Ethereum. The idea that you have this, restaking primitive, which then becomes naturally a part of the Ethereum protocol, would be really amazing at some point. So that's what we are hoping. I mentioned a little bit about things like MEV, right? Like opting into threshold encryption. Right? There is discussions in EF whether Ethereum should have native encryption in the mempool, and it's a contentious topic. And if we had a modular like lane where some set of block proposers committed some portion of their block to encryption, and we test it out as a community, and if there is real value or real use cases that can be built on top, and how much people are willing to pay for it, what other issues may show up because of it, all of these become clear, then those could then be internalized back into Ethereum. So we definitely want to be like a playground where builders like many of us here can go and play and create these interesting variations of ideas. In fact, the reason why we started EigenLayer is as a builder, we felt bottlenecked in like shipping new consensus protocols, right? Like you cannot, none of us here have the ability to go and upgrade the Ethereum consensus protocol itself, and rightly so, because it has to be battle tested at a different scale. But when people come up with new ideas, this can serve as a playground that we then all play with before the best ideas can then be internalized back into the core protocol.
Cool. Thank you for filling us in on that. If you haven't checked out, there's a post by Barnaby called Pepsi about internalizing EigenLayer into Ethereum itself. And there's many more interesting posts on ETH Researchers that we share on the YouTube stream there. Right, so EigenDay is a really cool use case of like restaking. Then there's also some talk about like a MEV Boost edition, I think called MEV Boost Plus. Maybe we could talk about that. Changing the MEV landscape is quite a cool effect of restaking. You would like to talk about that?
Yeah, sure. I think, actually this is one, some of this realization I came to pretty recently. If you look at like the whole MEV landscape, there is this subset of ideas around builder commitments, right? Like builders can make certain commitments to users. And then you start thinking about this, and to me, it doesn't really make sense that builders make commitments, because builders have no protocol role. In the sense that like builders is not a recognized role in the protocol. The protocol doesn't know who the builders are, and the builders don't have any kind of like native power in the protocol. So the people in power in the protocol are proposers. That's the only people who have power in the protocol. And so proposers, so the high level framework that I find like really interesting is block proposers who have power in the protocol. Why am I mentioning again and again about the power in the protocol is because when we think about as a community, is Ethereum decentralized? We're really talking about block proposers. Are block proposers decentralized? And so any kind of power really kind of emanates out of the proposers. And if we have a system for block proposers to make commitments that they have to hold on to, then what happens is maybe, like we all know, block building is a complicated process, and the MEV supply chain itself is pretty sophisticated. So we're not going to want to put pressure on every block proposer to also be a builder, right? That is not what we want. What we want is block proposers enter into commitments, and when block proposers enter into commitments, they have a mechanism to convey that they have entered into these commitments to the relay and to the builders. And so block builders then hold to those commitments that the proposers make, and relays, for example, validate that they have actually held to those commitments. So this is kind of like the high level view is proposers are the only like protocol enshrined players. And if block proposers restake, then they can opt into specific commitments on how they're allocating block space. And I think Swapnil alluded to our like initial post on this called MEV Boost ++. I'll just run through that. What that is basically a mechanism for, if you look at the MEV Boost architecture today, the goal of designing the MEV Boost architecture is to make sure that block proposers can continue to remain decentralized while block building, even if it centralizes somewhat, is still okay. But if you examine what is the benefit of having a decentralized block proposers, if the block proposers have no say in what transactions go into the block, because they're all selling on the MEV Boost market. So right now, it is possible for block proposers to opt out of an MEV Boost market or choose a relay or choose a builder, which complies with their ideological or other specifications. But they have to do this at the cost of like selling the block space to the highest like bidder. So if we ask this question, what more can we enable the block proposer to do? The answer is naturally, the block builder makes a substantial portion of the block. There's still space left in the block. Can the block proposers add on their own transactions to the end of the block? And this architecture was precluded in the MEV Boost original design because the only credible commitment we get from Ethereum is block proposers cannot double sign headers. If you sign one header and sign another header, you'll be splashed. That is the only like credible commitment coming out of the Ethereum protocol to the MEV Boost. And MEV Boost is riding on top of that commitment. So the way the MEV Boost is structured is the relay hands over like a header to the block proposer. The block proposer says, sign off on the header. And then now like the relay has an assurance that the block proposer is going to only propose that block. And, interestingly, we saw a break in this protocol recently, so we can get into that as interest demands. But I think the idea that block proposers are the only credible comment from block proposers is they cannot double sign headers. But in an eigenlayer world, like you're in a restaking world, you can actually opt in to a condition that says that I don't want to. I will sell you this portion of the block if you prove to me that I have signed a message saying that you bought this portion of the block, and later I don't include that in the portion of the block, then I can get slashed. So now I have a potentially credible commitment from the block proposer that this block will get included. And so what that does is now you're selling only portions of the blocks. Because you're selling portions of the block, you can add the remaining, whatever transactions you have, you can add at the end of the block. So that's the interesting idea with the MEV Boost++, where you want to participate in the MEV market and still express your own proposer agency. Each block proposer is unique and individual, and they have their own preferences. There's also other things like, you can extract end of the block MEV, you can do some other things at last minute MEV, things like that. So those are all benefits of this paradigm. But I think the meta version of this paradigm is that the block proposers are entering into credible commitments to do certain things. They don't do that things, that they're going to get slashed. I think there was a comment here on attestation.
I was asking about the role of the attestation committees as another way for the proposers to participate in some role. And I feel like restaking to some extent is is competing with the attestation committees as a solution to some of the things. I wonder about what are the limitations of one and the other.
Can you explain the attestation committee idea?
So the subset of validators, like a sync committee, like subset of proposers will have additional role for a short period of time, and they have to share information. So, well, in restaking, we only talk about the slashing and some additional verification whether the role has been executed properly for some voting or whatever solutions. In attestation committees, we expect some additional message sharing, gossiping, and some additional role in participation in the peer-to-peer network, and additional reward for participation in the committee.
Yeah. So the nice thing is, I don't know if this is an existing protocol feature or a proposed upgrade.
Yeah. So for example, sync committee is like the light client support is solved this way.
Yeah, exactly. So in some sense, actually, Ethereum itself is a medley of multiple protocols, right? Like this attestation committee is like a sub-sampling, like the sync committee is a sub-sampling of the Ethereum validators who are participating in this sub-protocol, which is the light node protocol. And what EigenLayer lets you do is to build these kind of sub-protocols permissionlessly. And that is a really interesting emergent feature. There's nothing that says that, when you restake in EigenLayer, you should not participate in peer-to-peer network. In fact, there'll be many protocols that actually require certain roles in the peer-to-peer network and so on. I think the way we think about it is certain actions are slashable, certain actions are not slashable. And, you derive economic trust only on the actions that are slashable from EigenLayer, but you derive trust in other ways for other actions. Like, for example, if you had enough of a decentralized committee, you may trust that a majority of that committee actually acts in the right way in picking up messages in the peer-to-peer network or whatever. But this actually the sync committee is a great example of both an interesting design in Ethereum, but where there aspects of the design can actually be improved. And the particular example is, if you take the light node sync committee, right, and they are basically signing 512 nodes are signing this message that this header is valid and so on for a period of, 27 hours or some number of days. And one issue with this is the economic security that you get from this is actually quite minimal. It's just 512 times 32 ETH by 2 or whatever, right? So you get very kind of light economic security, whereas there are 500,000 validators in Ethereum. So you're basically operating at 1,000th the economic security. And it makes sense why Ethereum protocol had to be designed like this, because you don't want to handle more than 512 signatures when you're a light node and so on. But the really interesting asymmetry that something like EigenLayer can exploit for this is all signatures don't have to correspond to only 132 ETH. One signature from a Lido validator can carry the economic security of all the kind of nodes that it's supporting. So if you had 512 signatures from highly restaked nodes, you get a very different kind of economic security that can be very powerful for both light nodes, for multi-chain bridges, and so on.
Thank you so much. So
committee is how you can think about restaking, right? Like the idea that you can engage in attestation committees of your own volition.
Yeah, I think that the sync committees is a larger protocol change, so it will compete for some of the most important enshrined parts of the protocol, but their EigenLayer is much more permissionless approach, which allows the extensions to happen without the core development changes and the client modifications. So that's definitely a big difference. Sreeram, thank you. I guess that maybe the conversation will continue. I have to drop off the stream. I'm heading to the event here, and also allowing for Tomasz to deliver some of the commentary on the data together with the DeFi team, and Jörgen Swapnil probably and the core team will lead the overview of the network and seeing if everything looks good. I have some information that the voting participation is going down, so this is something to look at. Thank you, everyone. Thank you, all the guests. Thank you, everyone who helped to prepare that. I'm heading off, but others stay. So if you stay with us, please do. Thank you.
Thank you very much. Thank you, Tomasz. Have a great one. Okay, thank you guys. So right now, so we've talked a little about the technical aspects of the Shapella and the upgrades. We've talked about the business. So let's talk about the future and what kind of new products we can have. So every upgrade provides Ethereum and the community with opportunities. So opportunities to build and have new products or improve currently existing products. So DeFi has been here, I would say, for 2-3 years right now. So it's still a fairly new concept, however, very exciting and incredibly dynamically growing and expanding. So right now we'll have Harsh and Basad, our DeFi researchers and analysts, talking about the liquid staking derivatives and how they may impact the market and how they can grow going forward. So I'll pass my voice to Harsh and Basad. So guys, take us away, please, and talk about LSDs.
Thank you, Tomasz. So with respect to liquid staking derivative tokens, we have seen that right now around 15% of the entire circulating supply of Ethereum is staked, and we expect that the staking percentage will keep increasing in the future. So with this, what we believe is that the percentage of ETH being staked on liquid staking platforms will also be increasing. Right now, Lido is the market leader, but then we have seen other competitors like Rocket Pool and Frax coming up. And recently, Manifold Finance also acquired a lot of validators from Cream Finance to start off with their liquid staking platform as well. An interesting concept that they are bringing is a liquid staking derivative token based on MEV. So they will be deploying MEV bots in order to extract the returns from the peg between their LSD token and ETH, and that is something that will be passed on to the stakers. So what we expect is that this will increase the yield. And yield is something that all the LSD platforms will be competing on, and that is something that will attract users. So this is something that will be interesting, and this is something that we will look in the future as well. So once liquid staking derivative tokens do come in, we believe that these tokens will be used in the DeFi ecosystem, and they will be probably they will act as an alternative to Ethereum that is being Ether that is currently being used in various pools or in various DeFi platforms. So another interesting point is the way that LSDs are being designed and how that impacts the composability. So Basad will talk us through the various different LSD designs that we have right now.
Yeah, so when it comes to composability, I wanted to mention a couple of things surrounding the design of liquid staking tokens right now, and what I think, or what we have looked into in the DeFi research team when it comes to making liquid staking tokens more composable. And the reason this is important is because if we do want more competition in liquid staking, we want new projects to be able to start their own validators and start their own token that will later that they can later integrate into DeFi, which is obviously important for the project to be successful. And what happens right now is that there are essentially two successful paradigms of interfaces when it comes to LSPs. So one of them is a token that accrues value. For example, Rocket Pool, as opposed to, say, a rebase token where the balance in your wallet increases or decreases algorithmically, depending on what the staking rewards look like. So the issue with some of that is that because the interfaces are different, say a new protocol won't be able to incentivize DeFi protocols to integrate their token into them. And that's an issue, once again, because we want more competition in the market for liquid staking to be as competitive as possible. So one of the interesting things we've looked into is something called the Liquid Collective. For example, they're working with Coinbase and Bitcoin Suisse and their goal was to standardize liquid staking derivatives. And the point here is that once again, we'll be able to start a new token that doesn't need to develop anything from scratch or create a new interface. They'll have a standard and they'll be easier to integrate. This also ties in with our idea that wrapped ETH should eventually give way to staked ETH or liquid staking tokens. And the reason, again, like wrapped Ether has been so successful is because it creates a standardized interface. And so far that has not existed for liquid staking tokens. And essentially, I mean, we don't see a reason for wrapped ETH to maintain its success in the future as well, because why would you own Ethereum that doesn't generate any yield for you when you can ideally successfully use liquid staking tokens in any DeFi protocol? And that is why composability and the standardized interface will become important.
So Harsh and Basad, you have just described like a lot of benefits of using or creating liquid staking derivatives. And what are the risks of such instruments or protocols? So where do you see any potential threats of more and more protocols using LSDs?
Well, one very obvious threat, sorry, Harsh, one very obvious problem, I think, would be liquid staking protocols, and I'm not going to name names, but they exist, that use only one type of consensus and execution client. I mean, if we want, obviously, if we treat liquid staking tokens as a derivative, of course, you want to maintain a one-to-one underlying value. But for example, I think anyone who is into finance would question that concept if you apply the relevant risk of running only one consensus and execution client. You would, at least I would, I think, question the extent to which the peg can be maintained in the future. If anything happens to that one particular client, I mean, the peg will be under question.
Okay, thank you. Harsh, anything else from your side? Do you see any other major threats?
This was definitely one of the greatest threats that was there with respect to LSDs. When we talk about centralized parties or centralized validators who are like taking care of the validation. So out there, we are also seeing a lot of innovations in this aspect, and we believe that DVT and other technologies that would come and distribute and decentralize the validator set would help alleviate this risk. But again, it's in the end a derivative token that is there and which has leverage against it. So there will be that risk that will always be there. But another risk that might be there would be whether users can instantly withdraw their tokens or not. For example, Lido is providing instant withdrawals for a specific amount of tokens, post which there are a number of days that will be required in order to withdraw those the stake tokens, which is in line with the Ethereum norms. So we will have to see how different projects are employing their withdrawal queue, and that is something that might make one project riskier versus the others. But at the cost of the withdrawal queue would come the yield as well. So if a project is providing instant liquidity, they have to maintain a buffer, and maintaining that buffer means that that particular amount of ETH is not being staked. So if it is not being staked, and yield is not being earned with that as well. So there is a cost and benefit analysis that needs to be done in order to understand the risk of providing instant liquidity versus the yield.
Okay, thank you. Thank you very much. Harsh, Basad, anything to be added? Do you see any other instruments or products being created because of this upgrade or thanks to this upgrade in particular?
Well, I think that there's quite a lot that pretty much every liquid staking token is introducing. I think one paradigm that we're seeing across liquid staking platforms is really a focus on trying to attract solo stakers to their platform. And with the recent, with the now live Shanghai, as we talked about with the credential switches, you can use the credential switch to switch over solo stakers to a liquid staking platform without forcing them to withdraw. So you basically will be able to say Lido through their staking router, which is going to be introduced in Lido V2, which will be live in the middle of May. They'll be able to allow solo stakers, without requiring them to stop staking, lose some of the yield that they would have otherwise generated. They'll be able to switch over to Lido, and they'll be able to take advantage of some of the properties that Lido will give them that do not exist in solo stakers. The very basic example being the liquid staking tokens, which a solo staker does not possess and only has to lock the tokens, but here they will be much more liquid, which is one of the examples why that would be beneficial for solo stakers as well. But since I do not currently remember the number, maybe someone does, a decent number of stakers on Ethereum are still like solo stakers. And so we believe that, and it's clear from the upgrades that various liquid staking protocols are introducing, that they will be fighting to get that market share of solo stakers to transfer to their platforms.
Okay, great, understood. So we have discussed potential development of liquid staking derivatives. We have discussed other products. So like we are 1 hour or 90 minutes after the Shapella upgrade. So it's been live. So what kind of metrics one should follow to stay on top of things, to make sure that the metrics are all like understand all metrics and indicators? So what kind of sources would you recommend to follow? I know you've been working on the 10 things to watch once Shapella goes live. So that's your recent research paper. So can you elaborate on it?
Yep, definitely. So through the research paper that we published today itself, the 10 things to watch post Shapella includes significant matrices that we will be following, and we advise you to follow since the upgrade has gone successfully. So number one, we would like the users to check out the MEV data that is out there. So with the withdrawals being enabled now, there will be a lot of MEV opportunities between the LSD tokens and Ether. And currently we are seeing that there wasn't much MEV activity happening on chain. So and the price and the peg between staked Ether and ETH stands at 0.99. So it's pretty much at par, considering that right now Lido has not started off with their withdrawal. So there is a risk that is still there in staked Ether. So we believe MEV is one of the important things that needs to be looked at even in the future. Along with this, we would check out all the pools that are there on Curve and Aave as well. So on Curve, we have the staked Ether and Ether pool, which currently stands at 52% and 48%. So any changes in this would signify the demand or supply for the LSD token versus Ether in general. Along with this, we would also look at the prices of all the projects of all the liquid staking platforms. So we have LDO token for Lido, we have RPL for Rocket Pool. So these are tokens that we would be looking at to understand if there is more interest in a particular project or not. Frax is another interesting project that we are looking at because they are providing staking, they are providing a stable coin as well. So they are one project that are providing us with a lot of services that we would like to gauge the user adoptability of their platform. So there are quite a few matrices, and we have mentioned and we have put in a lot of dashboards and links to them in the YouTube chat. So we would like the viewers to look at all those dashboards and follow them as we go into the next week. So through that, we will be able to assess how the Shapella upgrade has been impacting the industry.
Okay, thank you very much. Thank you, Basat. Thank you, Harsh. Our DeFi research team will keep the community and everyone up to date. We'll be sharing a lot of tweets, a lot of research papers, short, long, in the upcoming week or so. So please stay tuned and follow our researchers. So as we started with developers and engineers, let's go back to engineers and developers in our core team. So do we have Łukasz and Marek, or are you guys busy monitoring the situation?
Yes, I'm here, and also we have Dapplion. Dapplion has a good presentation about future of Ethereum, so he can also participate in this conversation.
Of course. So yeah, so Dapplion, feel free to be invited right now as well, and called. So guys, please elaborate and inform us what happens next, what's going to happen in the Ethereum ecosystem in the future. So what's on the roadmap, what's the impact, what's the potential impact on the market, etc. So let's see what's on what stream we are going to meet next.
Okay, so first of all, for 844, so this is for scaling Ethereum, and we hope that we will maybe not decrease gas prices, but be able to process more transactions. And I think this is basically confirmed that it will be included in next hard fork. There is a few EIPs that we don't know if they will be included. It is EOF, and it is about changes in EVM to optimize EVM a bit better. What's more, we have also big work for vertical trees upgrade, and this is again something for scaling Ethereum. Łukasz, you want to chime in?
Yes. So let me chime in and add some more context. So definitely the biggest thing is for 844, and this is probably the thing that is already kind of confirmed for the next hard fork, and the only thing that is confirmed to go to the next hard fork. The whole idea is to scale Ethereum, but not scale Ethereum on Ethereum, but scale Ethereum through rollups. So right now, the big problem of rollups is that they need to post a lot of data to Ethereum, and the gas prices are high, and it's not that great. And the idea is to let them do that in a special way that doesn't bloat the state permanently, while we can help them achieve lower gas prices when going through L1. And that's basically it. So if we can lower gas prices for L2s, L2s can lower gas prices on the gas prices, whatever it is, the price of the transaction on their side, and we can have a greater, cheaper ecosystem. But yeah, that's the next thing. Yorick, you want to add something on 4844?
Just a quick question on your side. How, maybe can you explain to people how the market for block space changes with 4844 and how the gas price comes down? Just like a really quick intro to that. Yeah.
I would say the block space market doesn't change that much because it will be similar, but there will be a new type of transactions called blob transactions that will behave in a very different way. So we are introducing something special, like a special use case. So if you're like doing normal transactions on Ethereum and you still want to do normal transactions on Ethereum, I wouldn't say much changes for you. But if you are a rollup or someone who wants to use Ethereum as a settlement layer or as a data layer, it changes for you a lot. So that's why it's not really a change for an average user from like Ethereum perspective, in my opinion, but it's a change from a rollup perspective. Or actually, I think there might be other use cases than just rollups, but I'm not sure. We'll see if any of things here emerge there. It would be interesting if people can figure out something different to do with this, but we'll see.
Yeah, how much of gas today is spent on L2 data posting?
Truth be told, I don't have this prepared for this question. It's probably you need to ask L2s. They probably keep that very tight loop on that.
Yeah, definitely. Yeah, maybe I can add on the consensus side. I think what's going to happen now, it's not as defined. It's important to know that what happened today was the closing of a very long cycle of development and deployment. You can consider that Bitcoin chain development started in 2018. We delivered the Bitcoin chain in 2020. Then we did Altair, the merge, and now validators. Withdrawals, so that kind of completes the saga. And there are definitely a lot of things on the pipeline on the research side, but there's nothing that everyone has consensus to do. So we have things like single secret leader election. We have PBS and charting, which have to happen, but there are still significant unknowns and problems that has to be fixed before going forward with those. So I would say what we'll focus now is on like small complementary things like moving the deposits into the protocol, some slight network changes like giving more stability to the random subnets. We also want to make available the beacon state root in execution. So we allow bridges and other applications to trustlessly access the beacon state. And yeah, I guess it's always good to slow down for a bit so clients have time to re-optimize and take care of things that are not features, so that like the clients don't implode, and make sure that like resource is good, features are nice, and take care of all these other like satellite stuff.
Okay, thank you. So looks like we're not expecting any large upgrade anytime soon. So there is still a lot to be done. However, we're not expecting anything, I would say, gigantic right now or massive, correct?
Well, EIP for it4 is going to happen for sure, hopefully this year. But after that, it's unclear what we will do.
On CL side.
On CL side, correct.
Yeah, but for execution clients, I guess it's still a few things. I mean, EOF and vertical trees. So
yeah, if I can chime in about vertical trees, that is a very interesting topic. So for example, for now, when you're having a wallet, right, and you're sending a transaction and waiting for its confirmation, most of wallets use some kind of centralized provider. And most of dApps use some kind of centralized provider or running their own nodes. But it's quite complicated, and there is some degrees of levels of centralization here and there. While, for example, vertical trees, if we have vertical trees, we can enable something called light clients. So there wouldn't be a problem for your wallet, for example, to join the peer-to-peer network for a brief period of time and start validating new blocks without syncing anything, without doing anything there. And you don't have to rely on any centralized provider to, for example, confirm your transaction. So wallet can be independent. A lot of dApps can get a lot more independent in what they do, more decentralized in a lot of ways. So that would be the things that vertical trees would enable in long term. They are the first step. The second, there are more steps to build those kind of light clients, to integrate them into multiple places. But yeah, that's another big thing that is coming. It can come as early as next year, but there's nothing set in stone. So we'll see. There are a lot of doubts. There are still a lot of questions, but prototyping is going good. There are already some testnets live. I think with Geth and Nethermind and maybe Eragon, I'm not sure, on the EL side. Because this is mostly an EL side change. Yeah, so really nice perspective on making things more decentralized here with light clients that are enabled by vertical trees and their witnesses. And maybe Ahmad wants to add something here.
Yeah, actually, what I wanted to do is for all of us to look into what could be included soon, especially for EL. And I would like here to share my screen to show the tracking issue that Marek has set up for Nethermind, showing all the possible upgrades that could happen in Cancun. And here you can see, obviously, 4844 is on the top. We have multiple PRs there, and transient storage, there is talk that it could be included. Precompiled for BLS, this will help some liquid staking providers, DVTs. Beacon state root and the EVM also will help DVT protocols and possibly liquid staking providers. Obviously, we have discussed EOF. There's a lot of EOF, as you can see. That's why we were saying it is a big change to the EVM, and that's why we are not expecting it to be included in Cancun, but we are working on it in parallel. As I mentioned in the beginning of the stream, also there is some kind of lenience from the core devs to include this EIP for self-destruct, which will only allow self-destruct in the same transaction as a create2, where it would replace the smart contract on the same address. And there is also get payload v3 with builder overload flag. This does not really need a fork to be included, but it's something that we're considering working on. Correct me if I'm wrong, Marek, here. I don't think this one needs a hard fork.
Yes, so the situation is, if we will be able to prototype it on any EL before Cancun, we will probably deliver it. But if not, we will bundle it together with Cancun.
Cool.
Yeah, maybe let's add a bit of context what it does. It's about making Ethereum more resistant to censorship. So basically, the idea is that EL can monitor some heuristics on transaction censorship. And if it thinks transactions might be censored, it might ask the CL to override their MEV behavior, right? So not to use, for example, MEV boost and take a local block from the that EL constructed, and that would help with censorship resistance. One thing about self-destruct, it needs to be removed from the protocol, except same transaction ones, because of vertical trees. So vertical trees won't support self-destruct as it is. So that's why we are considering deploying this change fairly soon to unblock vertical trees in one of the later hard forks.
Oh, and also the SSZ-ification, that's an interesting point.
Yeah, so the SSification is basically that we need the roots of the transactions and the roots of the receipts in the block header to match in the consensus layer client and in the EL side. And because of that, we are thinking about instead of replacing the Merkle-Patricia tree with SSZ Merkle tree instead, and replacing these roots to be, instead of Kitchak based roots, to be SSZ based roots. There is obviously a lot of discussion about that, and there is multiple open discussion points that the core developers are still not sure about, but it is something that is planned and we are planning to include as well. Another thing is EVM Max, which would help with, I believe, adding like how precompiles are done and stuff like that. So I think with EVM Max, there is, you remove a need for some precompiles because the EVM becomes powerful enough to do these complicated mathematical operations without the need for a precompile. Correct me if I'm wrong, anyone here.
Yes, the idea is to not add precompiles, but add this arithmetic operations. So the precompiles can be what we do in precompiles would be done on chain in contracts. Mm-hmm.
Yes, that's basically the idea. So another thing that I wanted to hear Lukasz discuss is like, what about Nethermind? Like, we want to know what is coming to Nethermind besides like just the Ethereum ecosystem and the Ethereum updates. I know that our developers are working on a lot of exciting things, so I would like you to share that.
Okay, I don't want to focus only on Nevermind, but one thing I'm seeing on EL side is reworking how the state is being stored, for example. And this is already, like said, let me say, done on, for example, for Aragon, and Besu also has its bonsai trees. And I think Geth is moving to a path-based storage too, slowly but steadily. And this is something also that is happening in Nevermind. So it's good to hear that I think all the EL side clients are changing here from, let's say, the more straightforward implementation to something more robust and more optimized. And we actually have two work streams in Nevermind. One, let's say, a safe work stream that's doing a path-based storage that is fairly, let's say, still conservative, using RocksDB, using our, let's say, still more or less standard view of the tree. But we also are experimenting with a very, let's say, crazy implementation that actually is a custom database on memory mapped files, and very, very special thing that has potential to be even faster and have very little resource usage. By resources, I mean more here CPU and memory, because in terms of raw disk storage, it still has to store the data. But yeah, this is something really exciting, but it still may fail. So that's why we have two work streams there. Generally, Nevermind, we have a lot of things coming this year, a lot of upgrades, a lot of optimizations, a lot of adding still features, but I wouldn't go there. Let's not focus just on Nevermind. Let's focus on the broader ecosystem. I see a lot of things, for example, relating to account abstraction, though I'm not an expert on it, which is also really interesting and really exciting. to be able to delegate to like contract wallets and things like that. But I'm not sure if anyone has more knowledge than that here than me. Maybe someone can chime in and give a little bit broader perspective. Not sure if anyone.
Looks like you are the most knowledgeable person.
Okay, I don't
which
feel
is a fair point.
knowledgeable enough on account abstraction to start a lecture here. But it's another thing. That's something. So there's so many things going on in Ethereum and on so many levels. I mean, there's call protocol right now. There is there are L2s. There are other protocols like we talked, like liquid staking. I've been a Ethereum core developer for like 4 years right now, and I've never seen like so many things going in parallel on so many levels. That's something that is really new for me. Like while we'll still be probably rate limiting things into the protocol because we have to sync all the client teams and we have to sync all the testing to be done. But I think like we'll have things ready all the time and going all the time one by one.
Can we get a quick check-in maybe on the stats to see if anything has changed on the front? Like, is there any recent developments coming out? Looks like attestations justifications and votes are back up, and things seem to be going well on that front. Any other interesting stats that have rolled out?
We're seeing there's just recently been a few more validators join the exit queue.
Okay.
There's been a spike here in the past hour, and also as we sort of hypothesized earlier, the circulating ETH supply we've seen increase now for the first time since the merge.
Nice.
So, it's going to plan more or less.
That's
okay, just to clarify here that the circulating supply is going up because like it doesn't like people are like withdrawing this ETH, and if you look at the total supply of Ethereum on like CoinGecko or whatever, you would notice that it's going up now instead of going down with the burn or whatever. But what we need to like make sure that people understand is that the ETH that went to the deposit contract does not go out of the deposit contract, and all the people who are getting their rewards or that are exiting, what they're doing is that we are minting them new ETH. So like they're not withdrawing their ETH from the deposit contract, they're just getting it from the protocol right away on the protocol level, not on the smart contract level or the transaction level. And that's why you might notice a total supply. Like I see that in the circulating ETH supply here, you deduct the amount of ETH that is staked in the deposit contract. And that's why it shows 101 million. And now they're rising because of the withdrawals. But in other platforms, probably CoinMarketCap or CoinGecko or whatever you use, you might see the total supply going upwards from the 120 million that we're used to seeing.
Yeah,
nice.
That's
Thank
right. When we had miners, all of the inflation was directly into the execution layer, so it could be sold immediately. Whereas with proof of stake, the inflation has been on the consensus layer, so there's not been any mechanism until now to get it, because as you say, you can't withdraw from the deposit contract. This is the first mechanism that enables it.
Amazing. So it seems all good on the home front, and it looks like people can start relaxing a little bit. I hope the core team is not under too much stress for the next few hours, and that everything keeps going very smoothly. I'm gonna maybe divert a bit back to question Lion asked earlier, which I just thought was very fascinating, but it's kind of a change in direction of the conversation about the amount of data and the amount of like costs of L2 like rollups onto L1. So I've just done a quick number crunch here, and I explore it. And then I think, Lion, on the front of like things coming in the Ethereum future, I want to extend the view past the next, like not the next 2 or 3 hard forks or soft forks, but like what are you super excited about, like long term, if you're still with us? Yeah, cool. So I'm gonna share my screen quickly. A second while I figure out how to do that.
Yeah, sure. So should I go about it, or do you want to show the numbers first?
I'd love to just quickly do the numbers, but I'm thinking not. Oh, there we go. Screen. Cool. So this is a nice little dashboard that's been prepared by a user BM Wolf. Cool. Can you see my screen?
Yep.
Yeah, cool. And we can see here that like the transactions data pushed by everything. This is the number of megabytes. Let's start with the price. So here the ETH cost in March, there was a massive spike 2023, and this is the amounts that they've spent in ETH getting all of the data onto L1, which is around like what 4,000K ETH, right? So this is how much they're spending in transaction costs. And then if we scroll down, we'll see here how much data they've been pushing. And I think it looks like in total for March, they've been pushing around, it doesn't say full sums, but 6K megabytes, right? Which is kind of interesting. So the question is like, how much of this can be offset by 4844 itself, right? And if you look at the spec here, the intention behind 4844 is to provide about 0.25 megabytes of data per block, which if you just do some quick numbers on like, okay, what is it, every 12 seconds, minute, days, you're getting around 54,000 megabytes a month, right? So there's still a lot of room to grow here in costs. So this is one of the externalities that this might bring down the price of gas, right? So that's a quick wrap up there. Okay, Lion, over to you.
If I can add one thing, this limit of data and blobs is currently very conservative. And the idea here is to deploy it and see how it's going, to like do not risk any stability issues, do not risk any peer-to-peer overloading issues, right? But the idea is to rise those limits in the future when we prove it's working correctly.
Amazing.
Yeah, and it's important to note there is not enough demand in L2 to fill even the conservative first target. So there would have to be some adaptative period where people figure out, well, probably it's going to be bots, like just arbitraging the hell out of rollups because transactions are so cheap. And then once it gets on the server, we'll see where the market stabilizes.
Great, thanks. So Lion, what are you thinking about like long-term future Ethereum? Like what would you like to see? What are you interested in?
Sure. So I just sent a link on the chat. Like if you can open now that you're screen sharing, it's this tweet by Vitalik with the infamous infographic, and this is everything that's on the research pipeline. I think it's a very nice snapshot of what's going to happen in the next like 5 to 10 years. I mean, let me know if you can open, or I can just explain, but it's going to just make more sense. I'm not sure. It's on the chat. On the Zoom
I've
chat.
just pasted the direct link to the roadmap. Yeah.
Oh, there you go. Cool. Yeah. So anyone interested, like this is fantastic. There are some really deep dives about what's going on. But what's most interesting is like the very end here is really significant changes when crypto allows, where basically the whole Ethereum would be snarked. And what we are doing now with the Verge that makes so much easier to execute the chain without needing any stake. If we could snark everything, literally a phone with just a few bytes could track the chain, and that's really exciting. Then yeah, so the idea would be to execute the entire EVM execution. Then we have things like on the purge. After that, if we go for state expiry, then not only it will be practically free to run the chain, but the size would be capped. So again, really good for the long-term sustainability. And the other point that's closer, sharding, doing EIP 484 is only the very first step. We will allow a tiny bit of data to exist, but there is still no data availability. So everyone has to download these blocks. If we want to go further, we would have to have data availability. That's still on research, but it's promising. Once we have that, then in order for you to check data availability, you only need to do like a few samples. So again, it will be extremely cheap. Just check a few bytes, and then you know the data is available. And let's see, what is there more? Can you scroll to the top section, the merge? Cool. Oh yeah, single slot finality. That's another very interesting point. So to make the Beacon chain possible, we use a dual consensus algorithm with Casper FFG, which has a ton of issues, and we have seen many of those in the past months, where the chain can become unstable. And also the fact that reorgs are possible allow MEV. So single slot finality would make in happy conditions impossible to reorg past one block. And that would be great for MEV and network stability, but it's a very complex protocol, and it really requires the chain to aggregate many more signatures. So it could be a problem. So we need some still breakthroughs in how efficiently we can aggregate BLS. But having that would be really nice and kill one of the biggest pains that we have on the Beacon chain today.
So Lionel, I have a question to you. So you've mentioned that it's a roadmap for next 5 to 10 years. So for every product, I think so, a roadmap for 5 to 10 years is an extremely long-term horizon. So what may impact this roadmap to be changed, or where do you see any potential functionalities that may be changed or may not come to a fruition?
Yeah, so everything that you see there is on active research. What that means is it's not actionable. It just needs really bright people to come up with brilliant ideas, or we still need some crypto primitives that are not yet developed, or that they are here, but they are not secure enough or not fast enough, like snarking the whole EVM. That's a frontier that a bunch of teams are pushing, but until that's feasible at an L1 level, it will not be adopted. So all of these streams are being done in parallel at different capacities. When things are available, or say that the chain needs them for some reason, say scalability, that's prioritized and then moved into the implementation pipeline, which it's much more streamlined. Like even today, as Nethermind folks were saying, we have a lot of parallelization, but at the research team, this is like a magnitude order higher. And yeah, if people don't figure out these research problems, many of these initiatives would probably just die out and go nowhere. But yeah, that's the nature of research.
Okay, that's super insightful. Thank you very much. So from the core dev point of view, what are you the most excited about looking at that roadmap?
I think snarking everything is really cool, because that's crazy. Like that means a light client with bytes of data can track the chain. Like Berkel tries are amazing and really efficient, much more than we have today. But with that's insane. Like it would become so easy, so cheap to track the chain that it unblocks so many use cases that yeah, it's really cool.
Okay, and what about you, Łukasz and Marek?
Yeah, hard to beat snarking the whole Ethereum, but yeah, a lot of things here, like vertical trees at the first step, but also PBS. I would like to have a more decentralized MEV than we have already. So yeah, let's say PBS and see how this goes, and have a very more confidential protocol on the MEV side and see how that goes. I'm excited about that, but that's a longer term goal.
Yeah, I agree with Lion. So snarking, PBS also, and maybe in full dunk sharding would be something something interesting. Not sure, Dapplion, maybe you know the current status of the research for dunk sharding?
Yeah, so dunk sharding, say the biggest component that was hanging for a while was how to shard execution. The previous design wanted to, I'm not sure if you guys remember these crazy charts where we'll basically have something like what we have Ethereum today with block producer and a fee market and execution environments, all of these shards, and that's incredibly complicated and really messy. So the current design, what it does is it does not shard execution. Execution can only be done in this one layer, which is Ethereum mainnet. We only shard data. So I would say on the consensus side, at the spec level, with now any network interactions, everything is pretty much final and done. Like everything checks out. There are no concerns and looks good. The problem now is the network. How can you do data availability sampling and all the custody games in a way that it's secure, safe, and fault resistant under highly adversarial environments? That's not clear yet. So there are many teams working on that. There are, I would say, some promising paths, but yeah, it's still, I would say, at least a year away into having an idea that clicks, and then we would need to like verify that idea, make sure it's safe. And again, because consensus problems, like you can write proofs and kind of mathematically prove that it makes sense, but everything that's not working is much more complicated, and you need testing and proof of concept and simulations to come to the conclusion that's secure. But yeah, it looks, I think it doesn't look impossible now. It just has to be figured out.
It seems like a long road ahead, and actually quite exciting to be able to pull these parts together. I mean, I always, one of the things I loved about the Ethereum ecosystem is the vision is always very grand, but like a lot of parts are tractable, you know. So that's really cool. I think that we have come to the end of our live stream time. So I would like to wrap this up and say a huge thank you to all of the fascinating conversations that have been had by everybody. A massive thank you to all of the partners, interested guests who are coming on to share their ideas about how such a big change, or well, nice final dot on the I, affects them and affects the entire ecosystem. And I also would like to make a massive thank you to the events and marketing team for putting all this together and holding it. And then, of course, the last big one is to all the core teams and to the testing teams who have been guiding us through another safe and successful fork. And I'm hopefully we don't see anything else in the coming days that has a negative externality to it, and everything just is smooth sailing. So guys, thank you very much. And to all our listeners, I hope you enjoyed it, had some insightful things, some cool insights, and had a look at both the past products and the future of Ethereum, which I think I learned a lot anyway. So thank you very much. And yeah, everyone have a good night. I know that you're all in like strange time zones right now, so please go sleep, and I hope you get sleep in the morning.
Definitely. However, we're going to sleep knowing that the Ethereum is in a good hands, so it's perfect. Okay, and that was a noise to make sure that we should finalize the stream probably. Okay, once again, thank you very much to all guests, to all builders, and have a great night, and speak to you soon. And once again, thank you.
Thank you, everyone.
Thank you, guys.
Bye.